hang on. One. I forgot to click a button. Kind of dumb. My bad, everyone on YouTube. Um, yeah, that was my bad. Um, Sorry. What was the last question?
If everyone agrees on it being true, what is the part missing that keeps it a hypothesis away from being proven to be true?
Oh, no. No one has an argument of why the statement is true, right? I mean, I could state the Riemann hypothesis, which is the zeros of the zeta function all have real part 1/2. I should say the non-trivial zeros, but the zeros in the right half plane, they all have real part 1/2. So that's a statement. It's direct. It's clear. We all know what it means. We verified it to like the first 10 billion zeros or whatever. Um, Yet we don't know why. So like no one knows how to like demonstrate through some type of argument. Yep, they all end up being 1/2. And so we're still waiting for a proof of why that is the case. We all believe it's the case, right? But we've never found a zero that doesn't have real part 1/2, right? Um, and so yeah, no one knows what whether it's true or not, right?
There was a Veritasium video they did on countable and non countable infinities.
Uh huh.
And if I remember correctly, um, one of the things that came out of it was a new axiom. So,
Yes.
could something be what stops them from just saying that's an axiom?
Well, that would be a different line of reasoning where you want to demonstrate that the statement is independent of the base axioms of, calculus, effectively, right? And if you did that, then you would then be able to say, hey, this statement cannot be proven. You could take it or its negation and create a different branch of math, right? And that's what happens with the continuum hypothesis, right? You can take the continuum hypothesis or you can reject it, and it doesn't create any contradictions with set theory, right?
Okay, so like
Mm-hmm.
making like saying it's true or not doesn't really matter because if it's either,
Mm-hmm.
nothing changes, essentially, correct?
Yeah, it's independent of the current axioms of math, right? Or standard axioms of math,
Okay.
right? And so
Could you explain to me the oh, sorry.
no, 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 go ahead.
Could you explain to me what made the one with the countable infinities different that made it not independent?
Well, I believe the statement you're talking about is the continuum hypothesis, and so let's make sure that we understand the set theory. So what happened in
I
set
don't
theory?
understand really anything, so if you please would explain it.
Sure,
I'm
no
just
worries.
throwing out, I'm just spitballing.
Yeah, that's fine. That's fine. So in set theory, we basically create the foundations of mathematics through sets. So we create numbers, we create, fractions, whatever, right? All of mathematics is built up from sets, right? In particular, we have an interest in comparing the size of sets. And so there's a question about how large do sets get. Now, in theory, if you don't have enough axioms, the only thing you know about are finite sets. So you have to take an axiom called the axiom of infinity, which is standard, which is that there needs to be an infinite size set. And the smallest such set that we take is the natural numbers. So that's all the counting numbers, which we assume has no end, but you can't prove such a thing, so you take that as an axiom. The natural numbers have no end, right? That you have the set of all of them. I should be clear. We can technically prove there is no largest number. It's just there is no systematic, careful set theory axioms that allow you to create the set of all counting numbers. So you have to take that as an axiom. You go, hey, let's just declare that there's a set of all the counting numbers. We know that there's no largest one, but let's just make that into a set. And we call it a set of infinite size, right? That infinite size set is the smallest infinite size set, meaning that any other infinite size set, if you were to put it in one-to-one correspondence with that one, it could always be made a subset, right? So all infinite sets are bigger than the set of natural numbers, which is the counting numbers, right? So the question is, what is the next largest set, right? Well, you can prove that there are sets that are bigger than the natural numbers, like the set of real numbers. So the set of all real numbers turns out to be strictly bigger than the set of the natural numbers. And so we know that as a fact from set theory, that we have the natural numbers and they're of one size, and then the real numbers are of a strictly larger size. So there's two infinite sizes. There's a smallest infinite, and then there's another infinite at least, right? Now it turns out there's an infinite number of infinites, but that's beside the point. The point is that there's at least two. And then the question becomes, is there an infinite that's between those two? Because the first one is the set of natural numbers, and the second one is the set of the real numbers. And so you might think, well, the real numbers are the smallest thing, at least it seems, that we could construct from the natural numbers. It's like the next largest set we could make. But how do I know for sure that I didn't just skip like 5 infinities or something? Like, how do I know that there isn't maybe there's a set in between them that's not this size and not the other size, right? And that's called the continuum hypothesis. The question is whether or not there's an infinite set between the real numbers and the natural numbers. And so it turned out, which took a little bit of time, that people ended up demonstrating that this statement is independent. You could assume that there is a set between the two that is not the same size as the smallest and the next. Or you could say that that's impossible, and both of those are independent of the set of axioms for set theory. And so you can take the continuum hypothesis, which is just the statement that no, the next infinity we found of the real numbers is actually the next actual infinite size. There is nothing in between. So you could take that statement, or you could take the statement that there's a set in between. You'll never be able to tell me what that set is, because if you could, we could have constructed it, and the continuum hypothesis wouldn't have been able to be proven to be independent. So we know the continuum hypothesis is independent, and so you'll never be able to tell me what the actual set is. You can just declare that there is one, and it doesn't create any contradictions in the math, right? Yeah.
Well, now you just pissed me off because I want to know if there is.
Well, we can just declare there is. We just say, take as an axiom, there is a set between the two, and it's not of the larger size or the smaller size. We can just declare it. Right? In fact, we could declare that there's an infinite number of sets in between the two that all have different infinite sizes, and they're all in between them, right? And so we could reject it in a lot of different ways. We could just declare that to be the case, and it doesn't create any contradictions in math. Yeah. Oh, sorry.
Thank you. That answered my question.
I try.
Left me with more questions, but it answered the one that I had.
No worries. No worries. Let's see. What is the concept of smart to you? People call chess players smart, but don't all of them have played and practiced thousands of possible games? I mean, anyone who play that much has to be good at chess. Yeah, but that's true of all things. I mean, if you do math for 25 years straight, you'll get pretty good at math too, right? So, I'm just saying, if you practice things, you get good at them, even if they're really hard, right? Why can't we cherry pick a set between the two? Like the set is all the real numbers and square root of minus 1 I. Well, we we can't we can't create a set between the two that fails to satisfy both, because if you could construct it, like actually tell me what's in it, then the continuum hypothesis wouldn't have been independent, right? So let's be clear. We have the natural numbers, which contains 0, 1, 2, 3, dot, 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 right? Then we got the real numbers, and this contains all the real numbers, you know, pi and a half and -2 and dot, 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 dot. And so these are the two numbers we're talking about. So on a number line, we're talking about all the numbers on the number line. And then for the natural numbers, we're talking about just the whole numbers on the number line, right? And so there's this set, and then there's this set. And what we do know, we'll give them a name. We'll call this, you know, Aleph naught. So that's the size of this set, whatever that size is. And then we'll call this one Aleph 1. And that's the size of all the real numbers, every possible real number. So I'm just declaring what the sizes of the set are. And sometimes we use absolute value notation to talk about size. So we'd say the size of the natural numbers is the Aleph symbol, and the size of the real numbers is the Aleph symbol. And so these are two different numbers, right? And this one is smaller than this one. And so what I'm saying is, in set theory, you can prove, and we know, that this is true. This is strictly true. We know that this one is smaller, and we know this one is larger. That's just guaranteed. What we don't know is if there's something between them. So something between them would be some set that the natural numbers is contained in, and some other set that is contained in the real numbers. I don't know what it is, but it would have some size, call it alpha, and that size could be strictly between these two numbers, right? And we don't know if this is true or false. But the whole point of the discussion is we showed that this is independent, meaning you could take it as a true statement, or you could just declare that it's a false statement. So you could just say, let there be a set where this property holds and it doesn't create any contradictions in math. Or you could just say, let's just say that it's impossible. There is no set where this happens. When you just declare that to be the case, and it doesn't create any contradictions in math either. If you do declare that there is a set where this happens, you'll never be able to tell me what's in the set, because if you could tell me what was in the set, I'd be able to verify if that set is not this size and not that size, right? So you're definitely not able to tell me what's in the set. Otherwise, I'd be able to definitively demonstrate if it's this one or that one, or neither, right? But that's we're not going to be able to do that. Mm-hmm. What is your PhD thesis topic, and how was your Viva? I don't know what a Viva is. You'd have to tell me. So my PhD thesis was in complex variables. I've been attempting to not dox myself, although the channel has grown way faster than I expected. So I imagine it will not take that long before everyone knows my PhD thesis and everything. But yeah. Oh, how was your defense? Oh, it was great. I thought it went fantastic. Yeah.
Wait, so like axioms can't be proven, right? If I understand correctly, they're just
Yeah. I mean, an axiom is just a
Well,
statement that we declare as true. It depends on what you mean by proven. Uh, Obviously,
I,
they can't be proven in the system that they're declared in because definitionally they're just declared to be true. So there is nothing to prove.
so I guess my question is like, when, at what point, like, what really makes them justified rather than arbitrary?
Well, that's when mathematicians get a bottle of wine and duke it out over several hours, right? I mean,
Okay.
I don't know. Like, two mathematicians will sit and be like, yo, but if you can't tell me what's in the frickin' set, then why would I ever think that this is a viable thing to accept? Is there any useful theorems that show up from it? And then the other person might be like, yeah, no, there's no useful theorems that show up to it. The only theorems that are generated by this are theorems about this set itself. What, how useful is that? So, like, we declared a thing to exist. We can't say what it's about. It has its own collection of theorems that show up because we declared the thing to exist. So some people might be like, yeah, screw that. Why would we say that there's such a set? It seems so silly. Just accept that there is no infinity between these two, right? And so, the people argue like that, right? That's how mathematicians would argue, right? So no one's going to question if you take a system and declare this as true or not, right? That's fine. But the when you're trying to write your book and you get your colleague to read over your notes or whatever, they're going to be like, "Wait, you want to demonstrate math without the continuum? That seems kind of silly, man, right? Like, why would we do that? Mathematicians also might, present stuff in reality. Like, I might, go, well, this just seems like it wouldn't even work in the real world, or this just seems silly, like thinking about how to like count things or something. Like, if we could count things in the real world, why would we think that there's going to be something in between these two? So the point is,
So
is that, yeah, yeah.
could someone that's like perfectly rational
Hmm.
reject one of the foundational axioms without making a logical error?
Of course, yeah.
Oh,
Well,
then what?
there's
I
whole
guess it's.
there's whole
I guess
books
there's no
on
answer.
Well, there's whole books in set theory of like tables of people rejecting different theorems and axioms and being like, no, that's a bad axiom, and no, we should do this axiom, and like giving their own rebuttals on why they think this one would be better or this one would be better, right? There's
But
no
then if
end to that,
every
man.
argument, so if they all bottom out in something unproven, like
Hmm.
where would knowledge end and justified belief begin?
I'm not sure what that means. So in abstract modeling, everything is made up, right? So like we can make up whatever we want.
Then how do we determine what's rational if we can make up whatever we want?
Whether it comports with reality. So like I
It
can I can declare a logic system any way I want, right? But if it's not helpful or useful in the real world, well then people are probably like, "Eh, that doesn't seem like a very useful, system," right? And so the books that get written and become popularized are those that are useful. They appear to tell us something about the actual real world. They appear to be consistent with other modeling we've had in trying to understand the real world, right? And so the point is that in abstract world, you can always make up whatever you want, but for mathematicians, the useful made up stuff is that which appears to work really well in the real world. And so we have a tendency to support that kind of stuff, right?
so are they like discovered or chosen?
Well, that's a big debate, right? I think it depends on how you want to look at it, right? We make up the terminology and everything. Like we make up the terms, we make up the way in which we're going to proceed with our reasoning. We make all that up, right? But normally trying to reflect something that we understand about the real world. Whether or not we're successful is different from whether or not, what we're trying to do, right? Um, and so, yeah, I'm not sure what to add to that.
Uh, if they're chosen, because I think I'm starting to understand a little bit as I talk about it, but if they're chosen, could you really draw like an objective moral argument from
Well,
an axiom?
so definitionally, so it depends, right, on what you mean. So definitionally, if you're talking about a made-up abstract model, axioms are declared objective things, and the derivation that comes from them is called objective, right? Like the mean value theorem is an objective statement about calculus, right? Um, and it's proven from from the axioms of calculus, right? So that's how that word would be used in abstract modeling. Now, if you're trying to use the word objective to talk about statements in the real world, I would, which is where morality is, right? Because that has to do with humans and our behavior here in the real world. Then I would have a tendency to say, well, obviously the word objective is not the abstract modeling word anymore. It's the word in which you're trying to talk about, human experience, the human condition, or whatnot. So anyway, the point is that the word objective is statements that are based on facts, data, and evidence, and the word subjective is statements based on your own opinion. And so, if you take that as your standard definition of objective and subjective when you're talking about the real world, then certainly you can make objective moral statements, because you can make statements that are not based on your opinion but based on research and data and evidence, right?
This is all so fascinating. I'm gonna have to go and read about it and join back and talk about it. Thank you
Sure.
so much
Of
for
course.
answering the questions.
Yeah, yeah. Oh, Jetstream. Okay. How's it going, man?
Hey Bobby, how are you?
Good, good. Doing well. Yeah.
Okay. I'm not gonna say too much, but I was hearing what the other guy was talking about, about Dix and basically about the axiom and about objective reality. I'm not sure if he's still here, but I was gonna maybe give him an idea, because when it comes to math, math is kind of hard to imaginary, because of imagination. So
Mm-hmm.
I was gonna say, for anyone who has the same question that he said, right? The best example that I could think of that we use as objective reality, but it's not really objective reality, would be about biology, right? When it comes to species, it's basically, taxonomy, right?
Mm-hmm.
Taxonomy is something that we all use, to declare different animals, different species, all that good stuff, right?
Mm-hmm.
But in reality, right, it doesn't exactly exist. Like, there's no such thing. Okay, DNA exists. Human DNA doesn't. Human DNA, when you say human DNA, it's like, oh, what do you think of human DNA? Oh, human DNA is about chromosomes. Okay, how much chromosomes does a human have? And I think I want to say about 46, correct? I'm not too sure, but yeah, 46 chromosomes. That's all our, that's our decision.
Mm-hmm.
Basically, I don't know exactly how it went down when people was making these names, but I'm going to guess that it was like a scientific vote. Like, okay, who agreed this is going good? And everyone raised their hand, like, all right, so this is now what we think about this, right?
Mm-hmm.
But again, when it comes to the objective part about it, human DNA doesn't really exist. There's no such thing as dog DNA, human DNA, cat DNA. Everything that's living, a living organism, has DNA. The animal kingdom is not definitive. It's not. It's the way I see it. Right? It's like a map. It's like a map on sand. What I'm basically saying is that these lines you can't make concrete lines on a beach. It changes here and there all the time. You know, I remember when it comes to between wolves and dogs, right?
Mm-hmm.
I think dogs and wolves. I mean, dogs was considered a different species back before the 90s, but now it is a species, but now it's just called a subspecies. So yeah, it's you know, it's really, it is arbitrary, you know, it's very like semantics if you think about it, but we just play along because, like, you know, like you said, Bobby, it makes sense, it's helpful, you know. I'm not saying that, you know, taxonomy is always right about everything, because it could change, it changes throughout time, but like Bobby was saying, it's a very helpful system or a tool that we use to navigate, you know, to the future. That helps anybody out. If does that make sense to you, Bobby?
Yeah, I assume you're critiquing the statement about whether mathematics is invented or discovered, right? And in general, it matters what what exactly you mean by that, right? On for the discovery side, people would typically argue, hey, you know the math we come up with is based on the real world, and we are part of the real world trying to discover things about the real world. And so math in some sense is discovered because all the math that we abstract about is fundamentally going to be based on our own understanding of the world, right? Whereas on the other side, you would say, well, but mathematics doesn't actually declare anything about the real world. It literally just makes up statements, right? And so someone would say that math is invented because every time you open up a math book, the very first chapter is let's declare these made up statements are true. There's no demonstration they have anything to do with the real world. No one presents any reasoning about why we should accept those. We just do, right? Um, yeah, yeah.
Yeah, exactly. Yeah, basically on a dot. Exactly what I'm trying. I just, you know, I just put it, you know, in a different perspective so people can understand. Because, you know, again, when it comes to math, I mean, at least from one of my professors, right, my old professors, he said the issue with math is that it's really hard to imagine, because how can you imagine math? So I like to get the math and kind of, you know, combine it what we use every day, but people don't realize it, what we kind of do. Basically logic, if that makes sense. But yeah, so just anyone just use, you know, if it's helpful, you know, use the taxonomy perspective, the species perspective. Because again, I'm pretty sure if, you know, anyone want to even like fact check what I'm saying, you could just go on Google or whatever, ChatGPT, you like, I don't know, Gemini, at it. Yeah, animal, like the species, like animal kingdom is not 100% definitive. It changes almost all the time. You know, it's there, you know, but it's not 100%. You know, it's like, how can I say? Animals obviously exist. Like, no shit, right? They exist, but how we name them, how we classify them, all of that is just, I guess, up for, you know, for a vote. There's even no like, there's no official definition of species. Like, it goes so many ways. So yeah, it's like if you think too hard about it, and I guess, like, you know, what Bobby said, you know, get the wine and start discussing about it, because there's no 100%. So yeah.
Sure, yeah. About the real world, there's no 100%. We could make
Yeah,
up an
yeah.
abstract world where we declare the things that we talk about are 100% true, but that, we declared that because we made up we
Exactly.
made it up, right?
Yeah.
Private Chicken wants to come back up, so I'll let him come back up.
Okay, that's fine.
So, I wonder if Flaw. I joined on the live again.
Sure, yeah, no worries. Oh,
if
did you ask that question in the Instagram?
yes, I did. Well,
Okay.
it's my problem with what the previous guy just brought up is that if these are not set concrete things and we use them to navigate as like us as a species and agree on this for us to navigate the world, then how can we use axioms to logically determine anything? Because if it's
we may
if it's
not,
made like
right?
then I don't know how we would even come up with a way to logically reason. How can we agree
by testing whether
other
or
than
not
just
I mean, by testing whether or not that reasoning comports with reality, right? Like we're in the real world. We go, hey, it seems like the law of excluded middle works really well, right? And then we then declare that as a principle. It seems like law of excluded middle works pretty well. Maybe we should make up an abstract model in which we declare the law of excluded middle as like an axiom or something, and see where that takes us, right? And that's literally how that happens, right? We see a principle, we think it's true about the real world, we declared it as an axiom in an abstract model, we check to see whether or not that tells us anything else that's new, right?
So what bridges the gap between that abstract model and us agreeing that it's founded in reality?
Well, how would you ever be able to show me anything is founded in reality? Like in an absolute sense, right? So in an absolute sense,
is my question.
Yeah, in an absolute sense, I'm not sure that's possible. Like there is no statement you could ever give me that I could like prove is true about reality. How would I be able to do that? I can prove things in an abstract model because I declared what proof is. I declared what it means for something to be absolutely true. But in reality, how would I do such a thing? The only thing I can present you is evidence. So like I could try to convince you that I'm right by showing you showing you a bunch of examples. Like, hey, is it true that you have been to the sun or not been to the sun? Like, is one of those guaranteed true? You'd be like, oh yeah, well, that seems true. Okay, well, what about, is it true that, you've visited, South Africa, or you've not visited South Africa? Like, is one of those true? Oh yeah, that seems true, right? Like, I can just present this over and over again, and you'd probably agree with me. This seems to be a property of the universe, right? But I can't like guarantee that. How would I guarantee such a thing?
So if you can't guarantee, what makes the axiom logic of reasoning more valid than others, apart from just collective experience?
Well, that's how the only reason that we accept anything is because of its utility and usefulness, right? And its agreement with other people and their perspective, right?
So could a different group of people on the planet have different things they agree about as grounded in reality? Like, let's take North Sentinel Island. Could they have concepts that are grounded in reality to them that aren't to us, and which one would be, like, how would we determine which line of reasoning would be more objective to go with?
Only based on the evaluation of the evidence, right? I mean, we would have to go over the examples and the evidence about the statements and the claims that are being made. There would be no other way. Like, I can't, again, there's no way for me to just say, oh, that this is absolutely true and there's nothing you can do about it. I can do that in a made up model because we made up what it means for something to be 100% true. But I can't do that about reality. That's just not possible, right? And to be clear, let's just, we're kind of hovering around it, right? We like the, philosophical statements of like, the law of excluded middle. We invented a logic around that called propositional logic, where we have truth tables and tautologies, right? Not everything in propositional logic comports with the real world, even though everything in propositional logic is a proven true theorem and a tautology, right? So like I can literally prove a theorem for you that you would say it is impossible for this theorem to be false. Yet we then do experiments in the laboratory and it comes out false, right? So when we say that we've made up logic, we really have made it up, because even our most held logic, the one that gives us the law of excluded middle, we have evidence that it is violated in the real world. And so what is the logic of the real world? I don't know. But we continue to try to explore it, right? So I only know up to the utility that I'm able to understand with respect to, the sensory information I have about the real world, right?
Once again, I appreciate it. Thank you.
Yeah, of course. So, Denshell, hey, how's it going?
Hey, Bobby. Yeah, this is Denzel. Nice to meet you.
Yeah.
I think Private Chicken said something that really struck with me. I just want to comment on it.
Oh, okay.
And it was about the fact that, if you have two different communities that both come to their own forms of truth, and why it's really struck with me is because, unfortunately for mathematics, that truth is universal in a way,
Okay.
where like a circle is a circle no matter where you are in the universe. And
Maybe.
I guess I want your perspective on maybe.
Yeah, maybe. I don't know.
That's true.
Well, so
That's
here,
true. Yeah.
here's
Go ahead.
where, like in general, I agree with you. Here on Earth, at this pressure and temperature and the interactions that we deal with, that where we're at, everything about propositional logic, circles, squares, it all makes perfect sense. I would take off points on my students' exam if they said, well, I declared an axiom that says otherwise. I'd be like, yeah, well, everyone thinks that that's a dumb axiom, so you're still going to lose points, right? So like we're all in agreement on how like the world works and how logic works or whatever. But as soon as we start like going outside of our bubble, right? For us to declare things are absolutely true is incredibly difficult, because how would you do that, right? Like for example, you're telling me about a circle. How do you know the definition of circle you're giving me is still true inside of a black hole or at the singularity of a black hole? Like, I just don't even know how you'd be able to tell me that that's true there. Like, a singularity is where there's an infinite number of energy in a infinitely small spot, or sorry, finite, well, whatever you want to call it. There's an infinite amount of matter, in a finite small spot, but it created a finite amount of gravitational force or whatever. You enter into that thing. How do you know circles still are the way you just described them? Like, you have no notion of like, like things just don't even make sense anymore, right? And you don't even have to be in the singularity. You can just cross the event horizon. So like, what happens when you cross the event horizon? Theoretically, at least according to the equations, the axis of time and the axis of space, they switch places. And so just try to describe that for me. What would it be like if the time you're experiencing became the space you were experiencing, and the space you were experiencing became the time you're experiencing? Like, is it possible that circles just don't even make sense anymore? I don't know,
I didn't think about that. Thank you.
Yeah, of course. Yeah. Let's see. I gotta restart the live thing. Okay, Instagram's back. Yay. All right, hey Jet, how's it going?
Hello, hey again. To give everyone like I guess an example of at least my personal perspective, because this is like
Sure.
a different subject, but it'll come back to it, right? So when
Yeah,
it comes
if you
to
want.
axioms, right? How some people, how you said that if axioms can collide and people don't agree with this axiom or people don't agree with that axiom,
Uh-huh.
the
Sure.
closest thing I could think of, right, is basically, about the famous debate about abortion. Is abortion good or bad or whatnot and everything, right? Um,
Well, that's a real
so
world
again,
thing,
yeah,
right?
I know. Okay, so I guess here's the example, right?
Mm-hmm.
So when it comes to abortion, right, the pro-life stance is about equal rights for a fetus, correct? You understand that they want a
Mm-hmm.
fetus to have equal rights like everybody else. Now,
Not quite.
is a it's like not okay, you're right, not as quite,
It's
but
that it's
from
more the other way, right? A baby's rights are above that of people, right?
yeah, no,
It's
but
slightly different.
yeah, no, to be like technical, right? Because a fetus by definition is an unborn baby. Now, by
Sure,
definition, like
sure.
strictly definition, a baby and a fetus is
Mm-hmm.
not exactly the same. And the way I put it this way is that a baby is an infant, a fetus is an unborn baby. An unborn baby
Sure,
is not
sure.
a
I was just using the word baby, but we could use the word fetus.
yeah. Just
So
to clarify.
in general, the position though is that a fetus has more rights than that of a general person, right? In particular, the mother, right?
I mean, from what again, I like what you're saying because to
Mm-hmm.
me that makes sense. But from their perspective, it's equal. Now, I'm not, I'm just telling you what they told me.
Correct. They may say that, but most of them have. Most
Exactly.
people that take that position haven't evaluated that position, and so
Yeah.
they're not even sure how to like articulate what it is that they actually hold to. And in
Yeah.
general, what ends up coming about in conversation is they actually hold that a fetus
The
needs to be
fetus more.
the fetus has more rights than that of the mother, right?
Yeah. Exactly. So okay. Granted, let's say that what they're saying equal is they're actually saying equal, right?
Mm-hmm. Mm-hmm.
Now, when it comes to human rights, you could say is somewhat of an axiom in this subject.
Yep.
Human rights do not apply to fetuses. Now,
Mm-hmm.
they do not agree with that because biologically, biology says that a human fetus is obviously a human, which is right. I'm not saying they're wrong. You look at the DNA, sure, 10 out of 10.
Mm-hmm.
Why not? A human fetus is a human.
Mm-hmm.
But it's not about, I mean, yes, DNA, all that's important, right? But it's about the personhood. That's where they disagree because personhood, at least by law, it's originally a law term, usually starts at birth. That's just universal, right? I'm not saying that it's, objective reality and whatnot. It's just what we all just voted. Oh, when do you think personhood should start? And I
Mm-hmm.
mean, the scientific basis of personhood is consciousness. But anyway, yeah, they don't agree that personhood starts at birth, right?
Mm-hmm.
But like you said earlier, like, if you can't challenge it correctly, like you said, like you can articulate, their stance, that's where, that's where they kind of fall under because, it's like there's consciousness and then there's, DNA. DNA makes us, I guess, the species of what we are, but our consciousness is what makes us who we are as a person. They're trying to say that a fetus should be a person. Again, just to let you know, everyone who's listening, human and person are similar but are not identical. They're both two different words, two definitions. But again, that's something that they also don't agree on. They don't agree with the definition of person. They think, oh, it's just too complicated and whatnot and everything. Blase, blase. But yeah, that's how it is. It's about personhood. It's not about if a fetus is a human or not. A human. You want to say a fetus is a human? Sure. Even though a fetus in general is what most mammals produce. But anyway, granted, for the sake of the argument, a fetus is a human. But is it a person? And that's where, everyone kind of, debates about that. But again, according to human rights, a fetus does not, apply to human rights, or human rights don't apply to fetuses. And that's their whole debate and argument. Oh, we should change that here and there. But then that's where what you said, Bobby, that's basically like the argument right there. It's like, but if you made a fetus, get human rights, then you're basically putting a woman below a fetus. And according to human rights, all people are equal. But if you make a fetus, if you say that, you can't, that's the issue with the pro-life argument, in my opinion.
I mean, and that's fine. I would just typically consider that categorically separate than talking about axioms in an abstract model, because axioms in an abstract model are things we declare as true. There's no you like when you pop open your real analysis book, you accept the axioms. If you don't like the axioms, then you don't take analysis, right? You go take a different class, whereas in the discussion of what humans should do or should not do, that's always going to have a very long, complicated consideration of, well, what's good for humans, what's bad for humans, what is it that we should be protecting, what is it that we shouldn't be protecting, what rights supersede other rights, those types of things. And so while I agree with some of your argumentation, the discussion itself isn't really about axioms, right? It's about moral positions in the real world, right?
Yeah. I'm saying it's not exactly, I guess, connected to what you're saying about abstract models and and the axioms, but it's like it's the disagreement part. How when it comes to, yes, they believe that pro-life believe that a fetus should have rights because it's a human. Sure, that's correct. Even though, again, like I said earlier, remember, taxonomy is also a social construct, so that's in reality also not true. But just for the sake of the argument, let's go with it. It is true and whatnot. Yes, human DNA does exist in a way, but at the end of the day, it's like they're trying to put one abstract model above the other one, but at the end of the day, personhood is what makes you a person.
Well, so there's a lot of moral positions are not solvable in an axiomatic fashion like other things are. They typically require a lot of nuance and deliberation, and sometimes take centuries, right?
Yeah.
The point is that I don't think you typically just take a position like, oh, we declare this statement true, and hence the consequences of it are this. Typically, there's going to be a more complicated discussion of like consistency. Like, well, if you think that this principle is important, right? The consequences of that principle is this thing, which you seem to be opposed. So you then require the person to provide you nuance on why they believe some principle, but their own principle violates some other statement or something. And that's typically where most moral discussions are going to go, is what is it that we really think should be important or whatnot. So, like for me personally, I have a tendency to argue about this specific issue from autonomy, just because I think that in general we really believe in bodily autonomy. People should own their own body. We don't really think that people should be able to sell themselves into slavery or anything. You shouldn't be able to like give up your body, in some contractual way. That should be not allowed or legal in any fashion. And so I think that that's normally how I would argue, is I think that that principle is more important than even other people's lives. And we see that principle playing out in many other aspects. We do not, we don't send people a message saying, "Hey, the hospital's low on blood. You've been randomly selected to show up and produce blood." We don't think that that would be okay, because we respect that, if people don't want to give blood, they don't have to give blood, right? And so bodily autonomy is very important to us. We think that it's above that of saving other people's lives, right? And so I try to stick with that same general principle. I think that that should apply in as many places as I think is appropriate, right?
Yeah. If anything, yeah, like that's, to be honest, that's kind of like my favorite argument too. But again, they, it's my favorite abstract model or axiom. Like, yeah, the body autonomy is definitely, it's like, I guess if you like take a step back, right, like a big step back,
Mm-hmm.
The pro-life argument, they think that abortion is committing genocide, right? But as a pro-choice as me, I'm more pro-choice. I think forcing a woman to give birth when she don't want to, I consider that slavery. So it's like
Mm-hmm.
genocide or slavery. Take your pick.
Mm-hmm. Yeah. Well, yeah, genocide's a strong word for people exhibiting, bodily autonomy. But anyway, that's beside the point. I have some questions to read through. Hang on. Love your
Yeah,
stuff,
no problem.
buddy. Thank you. I truly believe some individuals never experience true consciousness. Okay, sure. Fax Jacob Abrams. Okay, I don't know who that is. You'd have to teach me. Don't tell me my cat doesn't have a consciousness. Oh, okay. Your cat does have a consciousness. That's cool. Um,
Yeah, sure.
it's a pre-person, no bodily autonomy. Okay, I'm not sure what that means. The whole world is a moral battle, and everyone's interpretation of the world is different when talking about the issues of this magnitude. Sure, but we still have to make laws at the end of the day, and
Yeah.
so we can't like live in a world of like, well, we all just disagree, and we all just agree to
Yeah.
disagree. Like that doesn't work when
a,
it
a, a
you know
decision has to be made.
a decision has to be made, right? So
Yeah.
he meant categorically false. Okay, sure. That's a moral dilemma. Yep. The world can only be experienced by you, and you can believe the long-standing history of what is right. Okay. He's only here to ruffle feathers. No, I don't think so. Um, a belief can never be proven. Sure. I mean, it depends on what you mean by proven. You mean proven in an abstract model? That's probably true. But if you mean proven like in the real world, well, the word proof in the real world just means present me the evidence. Like, prove to me the
Yeah.
Earth goes around the sun. Present me the evidence, man. And so, yeah, people can prove their beliefs because they can present evidence that their beliefs are correct, right? Gödel style incompleteness considerations further suggest that, well, incompleteness only applies to first order logic systems expressing arithmetic. So it's very specific, right? Are you referencing Kurt? Yeah, Kurt Gödel. You'd have to be able to calculate every atom in the universe and their energy in order to prove something like that. I don't know. Genocide, blah, blah, blah. Okay. Consciousness in and of itself is very hard to define. Sure, that may be true. It's certainly a complicated thing, but we have lots of research on consciousness, lots of papers, and all kinds of stuff. So, yeah. Um, anyway, new people that joined, if you want to chat, just click the hand raise button and let me know. And then you can come to the floor and chat about things.
Yeah, I'm pretty much done what I gotta say for now. So yeah, you can take me out.
Oh, okay, okay, no worries. Let's see. Yeah, feel free to type a question or ask a question. There's plenty of different places to type a question. I got them all popped open, so ready to go. Yeah. Or if you want to chat, just click the hand button and raise your hand. There's a little raise hand button, and it lets me know. After my League of Legends game, I'm down. Okay, man, playing League of Legends. That's I used to play a lot of League of Legends. It was bad, very toxic. Also, hella fun. Toxicity scales with the degree of fun. True. That's so true. Yeah. Could it be possible to prove everything if you knew the position and directional energy? Seems to be a lot of evidence that we could not establish the outcome of certain experiments even if we knew every physical thing. Like if we knew all the initial conditions, it appears that there are physical experiments we still can't predict the outcome of. And that's incredibly unintuitive, right? Because, you know, at the macro scale, it doesn't appear that that happens. It appears our ability to predict things is entirely dependent on the accuracy of our initial conditions. But in many other frameworks, it appears we have an inability to predict things, even if we know all the initial conditions, and that's kind of weird. I always mute, so no toxicity. Oh man, but then you don't get that, you know, endorphinness and whatnot. Of every subatomic particle in the universe, sure. Sounds like Laplace's demon. I don't know Laplace's demon. I know Maxwell's demon. What's Laplace's demon? Laplace's demon. In the history of science, Laplace's demon was a notable published articulation of causal determinism on a scientific basis by Laplace in 1814. According to determinism, if someone, the demon, knows the precise location and momentum of every particle in the universe, their past and future values for any given time are entailed. Ah, gotcha. Yeah, that does sound like Laplace's demon. And so it appears, as far as we can tell, at least when we're talking about like quantum mechanics, that it is not possible to know the outcome of an experiment, no matter how much precision you know about the experiment. So there appears to be no such thing as Laplace's demon for certain things, right? Calculation in chess is a good example of that. Gotcha. Yep. There's no point in arguing with Lyapunov exponents against it. Yeah, okay. Could you give a specific example of how, if you measured, you couldn't get a decent prediction given the position of quarks plus others? Well, definitionally, right, a qubit in a superposition of being, let's say, either spinning up or spinning down, the definition of that being in superposition is that it is impossible to predict whether it's going to be in spin up or spin down when you actually measure it, right? And so qubits are in superposition. Qubits are what I work with. Okay. Well, Q modes. Gotcha. Hey, Mega Balloons. How's it going? What are my credentials? I have a PhD in mathematics. I don't understand superpositions. I thought it was our technology which limited the measuring of superpositions down to the accurate position. No, it is a fundamental fact that it is not possible to know certain measurements in advance to measurement, regardless of how much other calculations you have available to you. Like the universe simply doesn't allow it, right? In fact, that's precisely what is exploited when you build a quantum computer. A quantum computer precisely exploits the fact that there appear to exist things in the universe that have a superposition, i.e., an undefined value in a binary state, right? Not based on not just simply you don't know what it is, but that it really is in a superposition of both, and more importantly, that you can manipulate that superposition using logic gates, right? Working hard on algebra radicals. Okay, cool. Everyone loves radicals. It has to be somewhere, doesn't it? Explain the please. Okay, sure. You want me to talk about qubits? We can do that. Quantum information theory. Quantum information theory. Right? This is information that is encompassed in quantum mechanics. It is strictly more complicated than classical information. And so we want to kind of go over what that means and how does it work, right? Let's just go ahead and talk about the different chips. So like when I build a chip, out of, regular stuff, right? Regular wires or whatever, then the chip is going to do stuff, right? It's going to go through some logic gates and do some things, right? So it takes in some bits and it outputs some bits, right? So this is what a regular chip looks like, right? So a regular chip is a binary chip. It's a classic information system. Binary chip takes in bits and it produces output bits, and that's how a classic chip always works, right? A quantum chip, right, is similar. It takes in, it has wires and all that good stuff, does wiry thingies, right? And whatever it does, and they interact with each other in weird ways, and it takes in qubits and it produces qubits on the other side. And so classic chips and quantum chips are nearly identical, right? In the physical abstraction of how they work, they have logic gates, and they do logic gates on the input, and it produces an output. These have logic gates. They do logic gates on the input, and they produce an output. The difference here is that there are these things called qubits, and the qubits are not the same thing as the zeros and ones. They instead are objects that can be in a superposition of zeros and ones, right? And so the qubits over here are quite a bit more complicated. That means the logic gates are also a bit more complicated because they can operate on qubits rather than classical bits. But the point is that the architecture is the same. You set up a bunch of particles in particular states. They're in superpositions. they run through the system, and then they produce a bunch of stuff that's also in superpositions. And so there's a question about the, the dynamics of this information. Like, for example, if these qubits are just simply zeros and ones, like think of it like an electron. So what do we do over here? We take electrons and we put them in like an upspin or a downspin. And if they're in an upspin or a downspin, they go through the circuitry and it produces some upspin downspins, right? And so that's a classical system. Well, when we have an electron that's in a superposition of upspin downspin, then the question is whether or not this chip does stuff strictly more complicated than this one. So if it was simply the case that I didn't know if the electron is in the upspin or downspin, then this chip would be identical to this one. It's just I don't know what it is, right? Like it's like in other words, when I write that the qubit is in a, 50-50 state, like this, right? Then mathematically, I'm saying that it's in a superposition of both values. But you have to think about the physical apparatus. Is it really in a superposition? Like, is that a real thing? Well, if you think that the superposition is not a real thing, and that's just us stating that we don't know what it is, and that really this is in one of the two states, we just don't know what it is, then you're saying that when we put the qubits here, they would only be able to behave like the classical information. We just don't know what the values are, right? And so when they go through the logic gates, they would output some other ones and zeros, and it was just simply the matter that we didn't know what they were, right? Well, it turns out that that's not true, right? So way back when, they decided, how in the world are we going to resolve this? And so they came up with a program called the CHSH experiment. And the CHSH experiment basically said, hey, we've figured out a program. And that program can be put onto this chip, but it could also be put onto this chip. And that program is going to produce one of two outcomes. If these are truly in a superposition, right, then this program was going to, or would produce, an 84% outcome. I'm skipping over the details of what it actually does, but that's what it would produce. So that's if they are truly in superposition. Truly superposition. Right? And if it's simply a matter of you don't know whether they're zeros or ones, then when you put them in here and you run them through the system, you would always get 75%. Right? And in fact, for any classic chip, if you do the CHSH experiment on it, it always produces 75%. It never produces any other value. So all classic chips produce 75%. But if it really is in a superposition, i.e. it's not determinable whether or not it's a 0 or a 1, then you would get an 84%. And so they didn't know. They didn't know which one is it going to be, right? So then they flipped it on, and they ran it, and they ran it 1 billion times, and it came out to 84% over and over again, right? So we have very, very incredibly strong evidence that superposition is a real thing, and that the inputs to a quantum computer really are in a superposition, and that the electrons that we put there when they are in when we do the math and it says that this thing is in a superposition of 50-50, it really is in a superposition of 50-50. It's not kind of, sort of. It's not, we didn't know, we just don't know what it is. It really is literally both at the same time. How? We don't know, because that doesn't make any logical sense. But that seems to be the outcome, because Otherwise, we would have only gotten 75%, and we didn't. So, yeah. What makes a classical chip any different than a quantum chip if the quantum chip appears as a classical chip? Well, it has different logic gates, and more importantly, it interacts with electrons that are in a superposition. Now, how do you put an electron in a superposition? That's, the physicists tell me that that's possible, right? I don't know. As a mathematician, I wouldn't care, right? I buy the chip. The physicist told me that this chip does the thing. I go, okay, that's cool. So I turn it on and it does the thing, right? So what does it do? Does it throw the electron at some crystal that ricochets and now it's in a superposition or whatever? I don't know. It does something. It does something like that. Based on a 9% difference, that's how we've proven superposition? No, there's other experiments that demonstrate superposition, right? Like the two-slit experiment demonstrates that, light is a wave and a particle at the same time. I'm just saying, and to be clear, when you run this over and over and over and over again, you get 84% with like a standard deviation of 0.0001, right? So it's not like, who cares about the difference? Like the fact it's a 9% difference, that doesn't mean anything. It's just that it's just a number. You don't even have to think it just ignore the percentage. Just think of it as like a number. The number's either 84 or the number's 75. It's one of those two. And if you run it a billion times and you keep getting 84 over and over again, I mean, sometimes you get 83, right? Or sometimes you get 85, from errors, right? So you get a distribution, but the point is that the distribution's insanely tight. We've done it enough times. It's definitely not 75, right? We know it's not 75, right? Going from Algebra 2 radicals to understanding general relativity, how long will it take? As a slow learner, learning few courses per year. Probably take a little bit of time, certainly, right? Yeah. 85% because the measurement of the axes are separated by 22.5 degrees, and 45% for the polarization on the entangled photon pair. It varies sinusoidally with the relative analyzer angle, so the probability equals blah, blah, blah. Correct. Yes, correct. I assume that that's correct. I mean, typically people present it with a table of the different outcomes of the CHSH thing, but yes, there's a 85% chance of, 84% chance of winning, right? And so that's what it is, yeah. Does this mean that there is a quantum plus methodology yet undiscovered, which would yield a percentage of 100%? No, again, don't think about it as a percent. The percent doesn't mean anything. It's just a number outcome, right? It's just so if you want to get into the nitty gritty of specifically the CHSH experiment, if the CHSH experiment had come out to 100, then we would have basically been able to solve every NP hard problem on a quantum computer, and we can't, as far as we know. So 100% would have been like the world doesn't work. 100% would have been incredibly weird and strange. It would have meant that quantum computers are not just like better at calculating the classical computers, but they are the best calculating thing you could ever build in the universe, right? Best demos, in my opinion, are the 50-50 beam splinters for superposition. Yeah. This was the experiment, though, that gave the Nobel Prize, right? So this was the Nobel Prize experiment. And which year was it? 20... Was it 2022? I think 2022. I have to go look it up. I'm not saying 100% and 100% likely. You're saying I'm asking if there's a methodology for each number possible. No, this definitely could not come out to 84%. You can put them in slight superposition, so not the uniform state. And I think the CHSH experiment can be lowered, so it goes from 84 to something worse. I think down to 75. So you can make the experiment produce any number in between, but you can't get better than 84. It's not possible, right? And definitionally, you can't get below 75 because the whole point of the experiment is to maximize your expected value. So the lowest it could be is 75 because that's what you get with classical information. Mm-hmm. Mm-hmm. Oh, mm-mm. So feel free to join the chat or ask a question. You can type a question or raise your hand if you want to come up and chat. Any of those is fine. But you can go below. You can go below 84. You can go. You could set this up to go between 75 and 84. Yeah, that's not a problem. Does P equal NP? Yeah. So most mathematicians think P does not equal NP. I probably agree. I don't think P equals NP. If P equaled NP, boy, how did we miss that all these years? That's crazy. It's probably not. They're probably not equal. Yeah. Do you think AI is a net negative or a net positive for society? Oh my. It depends. If you have a good country instituting good policies and democratic and social policies that help your general people, right? AI could be a huge net benefit, right? Because if there isn't enough jobs to go around for everyone, but everyone's taken care of anyway, then who cares? AI is great. Like, I would love it if AI is taking all the jobs and we're then taxing the corporations to make up for that difference. And it's like, great. Who cares? That way every time you use AI, you can be like, oh my gosh, every time I'm using this, I'm literally helping fund the schools, the schools that my kids are going to, right? It's like that. I think that that's fine, right? What isn't fine is for human beings to get left behind. I mean, unless you want, warehouse burnings and riots and all that to continue, Greed and corruption will make it a net negative because that is part of human nature. Sure. That's why you need to spread out power, right? You need to have checks and balances. Power has to be spread out amongst many people so that things get changed, rules get put in place in a bureaucratic, systematic fashion, right? So in the world not based on morals, but the policies in place which dictate the nature of thinking patterns, which in turn lead to more policies of that kind. Mm-hmm. I don't know, maybe. I think a large majority of AI applications to people just won't notice, like neuromorphic chips. Sure, there are a large number of AI applications that we have yet to even scratch the surface with. There's all kinds of stuff that may come about. I typically don't think the AI revolution is going to be as big as they keep hyping it up to be. I think they just keep trying to look for more people to throw their money at them. Their numbers are pretty bad. They have a lot of borrowing. There's a lot of circular, funding going on. Um, there's enough contracts. There's like, I forget what it was. It was like $1 trillion in contracts in one quarter between like the top 10 companies or something. And you're like, what the frick? How the hell is that going on? So like, and then some people project these completely irrational ideas like AI is going to be this massive model, um, or this massive like multi-trillion-dollar industry or something. And it's like, well, what do you mean by that? Like, we can't. You're basically saying that everyone in, let's say, the United States, everyone in the United States will be spending double or triple on AI as they spend on the cars they drive every year. And it's like, I'm sorry, I don't see every person in the United States spending that kind of money every year. Like who wake me up when every family in the United States is spending $700 a month on AI, right? Like that doesn't, I can't imagine that in the slightest. There's just no way AI is going to be that profitable. It's not possible. AI can't be worth 10 times more than all of the car industries. This just makes no frickin' sense. I see you're debating SFT in a few days. Yes, I will be debating with Dr. Greg. So it'll be Dr. Greg and I talking with SFT. I forget what SFT stands for. Something flat earth. No, he's not flat earther. Something standing for truth, right? Standing for truth, something. Have you studied pedigree versus phylogenetic mutation and substitution rates? It will definitely come up. No, I haven't. I don't know a whole lot about those things. I will probably defer to my debate partner, who has I think a PhD in microbiology, right? So he's certainly more equipped than me in understanding biological stuff. What I do know is information dynamics. I know that stuff pretty well. So information dynamics is much easier to understand, and much easier to follow, right? So in particular, there's just no way that a Kynes model makes any sense, right? Like you can almost prove it as like a mathematical theorem, right? There is no such thing as discontinuities. So discontinuous starting places that morphologically change through stochastic pathing that then somehow magically lose their discontinuities. Like the discontinuities would still be detectable today, and yet we don't detect any discontinuities. So like this just doesn't make any logical sense. That's just not possible, right? And so I actually simulated it. I wrote a little program and like simulated it. So I have some like pictures and stuff for the debate on Tuesday that I'll go over. I'm like, well, here, there is no such thing as high dimensional data that can do this thing, So like you're gonna have to explain to me like why you're taking a model that like violates math, right? Like that doesn't make any sense to me, right? I think the large majority of AI applications too won't notice blah blah. I hate the necessary information arguments. Is it profitable? The answer is no. Everyone's broke. Yeah, that sounds about right. Let's see. Complex, standing for truth, yeah. Complex differential and Cauchy-Riemann equations. How does it make sense? Oh my. Complex differentiability and Cauchy-Riemann equations. Okay, I can talk about that in a second. I can send you a document that will help with everything you need to know. I just defeated him on the subject 2 weeks ago. Sure, I'd be happy to, take in other documents. I've also been talking with other scientists that have been emailing me. So I'm happy to take in emails and read over some literature stuff. That's fine. Just if you email me, email Dr. Greg as well. Just, CC us both. So I think that'd be great. There's so many defeaters for his nonsense. Yeah, that's true. Certainly. For one, mitochondrial Eve isn't the first and only woman in a population. Certainly. I mean, there's all kinds of issues, on how that works. But that's all for me personally as a mathematician. That's all getting into like the weeds and the weeds and the bushes and the grass. Like you're getting down there in like the soil. You're doing the soil samples. You're like pulling out the like me, I'm just at this like high level of like, yo, high dimensional data just doesn't even allow you like just tell me the probability. You pick two random places in like 1,000 dimensional space, right? You do some variation on them, and so every time step they move to a new spot, right? So they're making a path through this high dimensional space. Like, just tell me what's the probability that those two paths will get closer to each other than they do from their original starting places. Like, how long does that take, right? So I calculated it out, and it's like it's an unbelievable amount. So like at 100 dimensions, it's like you're talking hundreds of generations, right? But as soon as you go to like 1,000 dimensions, like 1,000 independent dimensions, it's like 10,000 generations for you to get those to you know get close enough to each other, right? If you go to like I mean, if you go to astronomical levels, like, hey, make the variation really tiny so that your steps are really small, so that it's the same as what you have in biology, and make your dimensions something reasonable, comparable to like DNA, you basically get, near infinite amount of time. Like it would take you billions of years to get two paths to like randomly, but maybe even more than that, hundreds of trillions of years for two paths to randomly end up closer to each other than where they originally started, right? So there is no such thing as like independent dimensional starting places that somehow magically look like they are related to each other. That doesn't make any sense, right? But that doesn't happen if you start from a single informational source. Single informational source can all sprout all these branches and things, which is exactly what we see. That's what the data sees. So the data looks exactly like we would expect there to be a single informational source. So there just is no such thing as disjoint starting locations. That doesn't exist, right? God is that single informational source. That's going to be the argument. Well, sure, he can certainly make fallacious arguments. In fact, I'll even concede to that to him. I'll be like, hey, if you wanna take unfalsifiable positions, we're done, right? Because that means you acknowledge the data, and that the data looks like the way it looks, and that you're then taking the unfalsifiable position that no one can demonstrate, right? And it's like, sure, no problem. Donnie's gonna melt down trying to keep up with you. I'm, I'm not trying to be mean. I'm just, it doesn't, I know how high dimensional data works. So it has nothing to do with biology. I don't know that much about biology. It just, you don't need to know that much for just the high dimensional data. Like the data, like DNA is 6 billion binary bits, right? So like when I'm talking at the level of like 1,000 dimensions, we're like at a trivial amount of like nothing, so like there's just and at 1,000 dimensions you already get like the impossibility of like magically being able to find the other person, through incremental change. Like it's just not possible, right? Oh, let's see. Mm-mm-mm. Wonder if I go to this. Okay, I can go there. Desktop, and then I can do. Hang on, give me a second. This. So like here, kaboom. So you guys are getting a sneak peek This is a simulated model where I started with multiple different random locations in a 1,000-dimensional space. I iterated it through doing some speciation events and population growth, and then killed off various species and just kind of did that repeatedly over and over again. The variance was 0.1%, so we're assuming each generation is changing at like 0.1% overall. And this is approximately how much those things move, right? They move at about that rate. Now, this is a projection in 2 dimensions, so it's hard to tell if these are separate from each other. Like, it's very obvious these are separate from each other, but like this one here has actually 2 groups in it, and it's hard to tell whether or not they're on top of each other, or like if you looked at them in a different dimension, they would be like really far apart, right? So what we do is we just take the end states. So I'll take all the end states, and then I'll just attempt to separate them. So here's what they look like when they get separated. Boop. And so when we look at something like this, so the point is that this is what modern animals should look like, or mammalian group, or the hominin group, or whatever group you want. They should all be little clusters with all their little mini species inside of them, like there'd be hundreds of little species in here, right? And they would all just be completely disjoint. And they would be obviously disjoint because you started in such high dimensional data. I started in 1,000 degrees, right? I'm in incredibly high dimensional data. There's just no way that these will ever even get remotely freaking close to each other. Like this 0.1% variation, one, that's insanely higher than what we see in actual biology. But 2, it's pennies in comparison to the dimension. The dimension's 1,000, which is nothing in comparison to what we see in DNA, but that's beside the point. The point is these will never get even remotely close to each other. The point is we do not see this. When I go out and I do taxonomical calculations or I do DNA calculations, it doesn't matter. I could come up with whatever features I want. It doesn't make a difference. This is never going to get anywhere near each other, right? And so this is exactly what happened. I just simulated it and it doesn't happen. It's never going to happen. It doesn't happen. That isn't what happens, right? So what happens if I start with a single starting point? Here's what normally happens, right? What you were saying. Yes. If there's a single starting point, then you end up with this, right? So this is an example of starting at some location, one point, and then that one point birthing different speciation events over time. And so this is plotted over time. It's going backwards in time. So the dark area is further back in time, and then it slowly starts splitting out, right? So this is an example of one particular simulation of starting at one point, allowing for all those speciation events in the exact same way as the other data. And what we see is all of these lines of relationship. You see, lines of variation changing through morphologic time. You see little branches splitting off. You see, the end state showing up, right? So this is exactly how we see it in nature. This is like almost identical, right? And I literally tried to make this as gracious as possible. I tried to have all these little groups be as tightly coupled as they could be. So when I go to kill off the species, it kills off everyone that's not like tightly coupled to the species to try to make kinds out of it as much as it can. And it just simply doesn't happen. The point is that this is what modern data actually looks like. And that's why modern data looks like it has lines all coming out of the same tree of life, right? It's all coming out of the same place. And that's not... The point is, I don't have to know anything about biology. That's what just naturally happens with data, Try to find your email. It isn't in your channel. It's all over the place. It's on the YouTube. It's in the Discord and whatnot. But I can put it here. It's fine. Axiomaticreasoning@gmail.com. There you go. What's your favorite math operator? My favorite math operator? Probably e to the d. Or e to the alpha d if you wanted to be specific. So it looks like this. E to the alpha D. That's my favorite operator. Let's see. So I have some other pictures. These all kind of look similar because of I'm not doing like super fancy. So they have a tendency to come out triangular because it's high dimensional data, and I'm doing PCA. So the x-axis is going to be the widest, so it'll have a tendency to sort of look bimodal when you project the data, and then the third axis shows up, or the third rung, I should say, shows up when it goes to separate that bimodally again in the other direction. It's not bimodal data, but it's attempting to try to find the axes of greatest variation, and so that's typically what happens. But again, look at all of this. Like, you can literally see the variation over time. Like, look at this line right here. Variation over time. Variation over time. Variation. You literally can just you could take all of these clusters and find the midpoints and then literally connect this up with lines, and it would look like a tree of life. You'd have a tree of life, right? Like everything's related, right? Yeah, I know. It looks like a funny tree. And this one is with s equals 2. So I'm only doing like speciation events on the order of 2. So like when they happen, it'll be like 2 new, it splits, right? But in reality, in the real world, we expect that there could be many more than just 2, And anyway, the point is, this is what happens when you do stochastic pathing through high dimensional space. If you start at some spot and you slowly change that spot's information, it's going to make these stochastic paths through the entire, system, and it's just going to keep doing that and keep growing out in a tree-like fashion, Again, this is what happened when you try to do 10 separate species in different starting locations, and then you try to speciate them. They don't get anywhere near each other. None of these groups are mixing. They're all not mixing. And we can literally separate them, and none of them are even close to each other. I'm thinking of trying to calculate this out directly, because I could take these bundles in high dimensions and actually figure out their distances. And then I could express it as a percentage. Like it looks like they're close, but really it might be like, 98% empty there, meaning that like however much amount of variation you think you've done so far in your cluster, you need to do 50 times more variation to try to get even remotely close to the next cluster. And it's not like that would even accomplish anything. Like if 2 of these clusters got close to each other, would that somehow be suggestive of what we see the tree of life look like? No, it wouldn't look like any, because we see what it looks like today. It looks like lines, right? It doesn't look like that. So, Oh, I did the classic wave. There you go. Not related. I just thought everyone would like to see an animated picture. Let's see. Blah, 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 blah. It could be used as one part to make wealth inequality even worse, and governments will become more totalitarian to control the populace. We all pray that, or think or hope, that we're not going to turn into that. That would be bad. Who's your favorite mathematician and why? Oh, Gauss. Gauss is my favorite mathematician. Why, if that's the case, why aren't we going down a borehole which can't be reversed? I don't know. Morals, blah, blah. Greed and corruption will make it negative, yes. People said the same thing about computers when they first came out. Sure. I've read the monk-written book in early calculus, which was overwritten by children's stories. Does that mean that there maybe is math or logic systems which have been lost? Highly unlikely. We have incredibly good documentation on what people knew about mathematics way back when. This even came up in a discussion I had with someone on some pyramid stuff, and it was like I literally just had to ask him, the Egyptians didn't know how to do fractions, so how like we know what they did, right? They wrote it down, right? Like so like we're now we see the what they were doing. It was bad math, right? So like how could you say that they had like more sophisticated math? They clearly didn't, you know. Could you dive in your PhD thesis? Man, I wish I could. I'm trying to not dox myself, but maybe one day. I don't know how long that'll last. I'm sure people will figure out who I am at some point, and then yeah, I'll put it on my merch store. You can go buy a copy. You know, it'll be great. So if you want a hard copy, right, you can just download it for free. I'll probably stick it on the Discord or whatever. I don't know. Give me a few months, man. I don't know. This is all new to me. This all just happened so fast. Back on to superposition. If you froze time or slowed it down to 0, would superposition electron of spin up or spin down still be both? I feel like this is going to be a physicist question. You can't mathematically prove if there is God or not. We are limited to our 6 senses. That makes us flawed to a whole spectrum of reality. Maybe. I mean, that just sounds like an unfalsifiable statement. Okay, let me restart this. Kaboom, 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 kaboom. Copy. Go over here. Click, clicky thing. Click, click. This part. Control A. Paste. There we go. Click, click, and click thing here. This thing. Click this. Do that. Do that thingy, and then put. That done. Confirm and kaboom. Then I can click that. Okay, cool. Back online. I don't know why Instagram only lets you stream for an hour. That doesn't make any sense to me, but that's what they do. So, you know. Okay, so some other questions in other places. All right, I'll send you an email. Great, awesome. The IG live ended, so I migrated here. Yeah, I apologize. I don't know why the Instagram only lets you stream an hour. Like, what is wrong with them? Why would they only let you stream an hour? I don't understand this. No other platform does that. Who does that? What's wrong with Instagram? Like, I don't get it. Then again, Facebook. Do they do lives on Facebook? I don't even know if they do. Not like it matters because my Facebook isn't even like doing well or anything. I stopped posting to Facebook because it won't even let me. It doesn't even care. But Instagram, they like my content, so you know, I guess it keeps going. Conjugate transpose. Yes, there is such a thing as a conjugate transpose. It looks like a funny tree. Yeah, that's what I was thinking. When are we getting the Terrence Howard debate? Oh my, I don't know if I could handle that. That would be certainly interesting, though. I'm happy to talk to anyone that spreads misinformation or disinformation. I think that's great, you know. You can't hear me on Instagram? You can't hear me? Other people have been able to hear me on Instagram. I think it might be on your end, man. I'm sorry. Oh, and you can't hear me, so you're not going to hear that. Okay, let me type it. I think that might be on your end. Sorry. Gauss is a hottie. Oh yeah. Yeah. Gauss is amazing. Yeah. I thought the Egyptians used unit fractions. The answer is the electron would still be in the superposition. So the Egyptians, they had a semi-fraction system. Basically, the fractions 1/2, 1/4, 1/8, 1/16, 1/32, they all existed. But they had no concept of 1/5, 1/7, 1/9. What they would instead is they would calculate out the other fractions to get further and further accuracy. They didn't have a fraction symbol. This was all very tedious work, but basically all of their arithmetic was kind of done on doubling and halving. They loved doubling and halving. It was like everything they did. So everything was based around doubling and halving, and so they just had no concept of 1/5. Like how do you do a fifth? Well, you don't. You get better and better estimates of like having something to get closer and closer to a fifth, right? Are you a Freemason? I don't know. I don't think so. I mean, I'm free and a Mason. I don't know what a Freemason is, honestly. Um, let's see. Da, da, da. Stay with the clip. Yeah, so if you just join the Discord, you got to click the little hand button, and then it lets me know that you want to come up to the stage, and then you can chat about whatever you want. So if you're wanting to chat, you know. What is your take on the pyramids lining up with the coordinates of the speed of light? Certainly a coincidence. Yes. Yeah, they if they knew about the speed of light, why wouldn't they have wrote anything about the speed of light? They wrote all kinds of other shit, and they also wrote that they did shitty math. I mean, they literally have we literally have tabular data of all the times they were doing calculations and how crappy their calculations were. So like we're aware of their crappy calculations, and then we're like claiming that they knew what the speed of light was. This is just silly, you know. Don't get me wrong, they did some amazing things, right? I don't think people realize how old the Egyptians are. And I guess we're talking about the ancient Egyptians, the ones that built the pyramids, right? Hypatia of Alexandria, the Egyptian queen, right? At the time of Alexander the Great, she would wake up in the morning and look out of the window of her palace, and off in the distance were the pyramids of Egypt. She had no idea who the hell built those pyramids. So keep that in your mind of how old the pyramids of Egypt are. They are older than literally the queen of Egypt, Hypatia of Alexandria, right? That's how old they are. She had no idea who they were. The Egyptians, like in the time of the Greeks, when we're thinking of like Plato and Aristotle and all that stuff, right? The Egyptians didn't know how to read the hieroglyphics of the pyramids. That wasn't anything that they knew about, right? A lot of ancient Egyptian artifacts were lost in time. Yes, certainly. What do you do for work? I'm a mathematician. I work for a private industry. I work on everything from encryption algorithms to coding algorithms to signal processing to, designing or helping with chips and things and whatnot. I do a lot of neural networks and machine learning and data analysis. So a lot of data analysis. Recently, my work, they wanted to know whether or not quantum computing might be important. And so they funded me to go get a certification in quantum information theory so I could give some presentations and, tell people whether or not this is a worthwhile thing or worth investing in or whatnot. Well, also it would imply the Egyptians used meters for that to match the speed of light. Yes. You ever dive into the post-quantum cryptography? Yes, I've read on that stuff. Typically, post-quantum encryption is based in lattice theory, and the reason that we do it in lattices is because we need to avoid groups, right? The moment you introduce groups as your encryption backend, it becomes breakable on a quantum computer because the discrete log problem has been solved for all groups. I mean, technically it's a caveat. All groups with a composable finite polynomial time algorithm for their operator. So like addition on integers is a polynomial time algorithm, and if you compose it over and over again, it still remains a polynomial time algorithm no matter how many times you compose it. So as long as your operator is a polynomial time algorithm, then your group can be solved, the order of every element in your group can be solved in polynomial time, and that's known as Shor's algorithm, right? Yeah, short vector problem or LWE don't reduce to the abelian hidden subgroup. Yes, correct. Yes, and that's why they keep doing it. What do you do for work? Oh yeah, I already answered that. A lot of Egyptian artifacts were lost. Egyptian history for ancient Egyptians. Yes, they had Egyptian historian was a job for ancient Egyptians. Yes. Favorite Aristotle quote: "We are what we repeatedly do, therefore excellence in a habit, not an act." Oh, fascinating. You're one of the smartest individuals I've ever come across on Instagram. Oh, okay. Well, thank you. Follow, like, subscribe, share with your friends and all that. Favorite Socrates quote: "A wise man is a man who knows he knows nothing at all." Sure, yes. What makes an encryption system hard to crack in your work? What makes an encryption system hard to crack? Well, so encryption systems are when you take data and you turn it into another form, and then it's incredibly difficult for someone to reverse that, right? Um, and there's a lot of nuance there, right? Because it depends on what level of encryption you're after. Like, in theory, you can build a perfect encryption system that can never be broken by anyone. That would be called a one-time pass. So what you do is you generate random ones and zeros, you XOR it with your data, you then take that key, that ones and zeros, and you print it on some piece of paper, you put it in an envelope, and then you physically walk it to the person that you want to give it to. You hand it to them, they pull it out, they scan it in, they get the data from the email or whatever, they then XOR it back, and then they get the data recovered. And that's a perfect encryption system. That encryption system cannot be broken, right? You can prove it mathematically that that's a perfect encryption system. So encryption is a lot more about the subtleties of how not to do that dumb way of encrypting, because that is clearly tedious, right? Doing one-time keypads is not good. So what we need is instead, how do I create like huge swaths of encryptable key material from a small key? Okay, we have something like AES 256, great. And then more importantly, how do I do things like, I don't know, send you encrypted stuff, but you and I have never talked to each other before? Like, is there a way for us to like start a communication and then figure out that, we know who we're talking to, and then be able to send each other encrypted stuff, and no matter how much someone reads in between what we're doing, they won't be able to figure out, the encrypted material. So they can see all the exchanges, but then they can't figure out the encrypted material. And so those algorithms become quite a bit more complicated and quite a bit more nuanced, right? Those. We can talk more in depth into those if you wanted to. We could go into RSA or something if you really wanted to, but that's the whole point. Is encryption is about like, how do I talk to you, and you and I haven't met before or something, such that if anyone's listening, they couldn't understand what we're saying, right? Let's see. What do you think about the next breakthrough in math is going to be if you were to speculate? Specifically, what field do you think it would reside in? Oh, I don't know. I imagine people talk about breakthroughs typically when it's something really, really big, like any of the Millennium Problems or something. What is the next Millennium Problem that's going to be solved? I don't know. I feel like we should have figured out maybe the what's the singularity one? Navier-Stokes equations. That feels like something like tangible, pretty real world. Like why haven't we figured that one out? That seems weird. I don't know. Is it like akin to trying to solve, the exact formulas for how plasma works or something? I don't know. That's a complicated one. Let's see. Wow, that's a insignificant standard deviation. Okay. How many sigma is 75 away from the mean? Way more than 5 sigmas. This single qubit superposition gives the CHSH quantum result. That's incorrect. Okay, I'm not sure what you mean by that. Early Christian quotes. Let's see. Visuals, drawing, or some sort of explanation with a pen. What makes encryption hard to do? So you want... is there an encryption system that is completely impossible to access from the outside, or is it just impossibly difficult? Impossible to access from the outside. Okay, so maybe I think people think of encryption as like some mysterious thing, and it's not all that mysterious. So you're over here, right? Here's Bob. Hey, Bob, how's it going? And then you go over here, right? And this is, Alice, right? Here's Alice. Hey, Alice, how's it going? So Alice and Bob, they want to talk to each other, right? And so encryption just means that Alice and Bob have some type of functions, we'll call them F and G, such that if Bob takes some info and runs it through F, it turns into some number called, E. And then Bob sends E, right? And then Alice gets E and goes, oh, I have G, and then runs E through G, and it turns back into I, right? And then the info was successfully sent. And so the point is that if someone was, observing, right? I don't know how to make an eyeball. Is that an eyeball? So if someone was looking at the exchange, right, they wouldn't be able to see the I, right? They can't see it. And so that's what encryption is. You have to have these two functions. So if we know a bit about F and G, just mathematically, right, if you have a function that takes in an I and turns into an E, and that function takes in an E and turns it back into an I, then typically G is what is called the inverse of F, right? That's the inverse of F. And so there's questions about how to get these functions here. You could imagine that Alice and Bob met earlier. They came up with an algorithm to create F and F prime or F inverse, and then they went their separate ways. So they both made the function and they went their separate ways. Other times there's a third-party server where these things are registered, and Bob can just look up, Alice can look up what Bob's inverse function is, and then use it, or vice versa. I should say vice versa. So Bob can look up Alice's encryption function and then encrypt the data and send it to her, and no one can read it except her, who has her inverse function, right? And so there's different methods to try and make it to where they can figure out the F and the F inverse, right? But the point is that encryption is simply about taking information, turning it into something else, and then sending it, and no one can read what that something else is along the way. Your internet service provider can't read it. Any of the servers along the way of your internet service provider can't read it. No one can read it, right? All they see is the number E. They have no idea what E is because they can't undo it, right? So that's what encryption is, right? And again, if we want to go into something specific, we can talk about something specific. The ones I'm familiar with are like RSA or Diffie-Hellman or elliptic curves. Those are like the classic three, right? What do you think about a breakthrough math? Blah, blah, blah. My favorite person of all time showed one-time pads are unbreakable. Yes, Claude Shannon. Hey, Alice. Yes, thank you. Do you believe in a soul? No, not really. I enjoy smart people. Oh, thank you. That's very kind of you. Shamir, secret sharing is pretty cool. Yes, there's a lot of cool math algorithms. Thoughts on AI providing a counterexample to the Jacobian conjecture? Yes, so it's certainly fascinating that that was possible. I don't have as much hype as other people have had. Like, we're basically saying AI said, hey, let me look for a counterexample, wrote some code, and then tried all the base cases, and boop, it landed on one. And you're like, okay, so like any human who had even remotely attempted to do that would have found that exact same counterexample. It wasn't like it was a 2 variable cubic? I mean, it wasn't like, we're not talking like a massive counterexample here. This wasn't like, it was just, kind of out of the blue. Like, oh, wow, So like, does that really demonstrate that AI has like some sophisticated, crazy way to do stuff? Not really. I think it just demonstrated that it did the first thing we would have thought to do, which is to write up an exhaustion, and it happened to hit a counterexample literally trivially because it turned out that there was a trivial counterexample. Lucky break, right? Maybe I'm being a little harsh on the AI, but it didn't like it didn't have to like invent new terminology and then develop a whole new theory and then prove a bunch of theorems and a bunch of lemmas and eventually in a roundabout way get to the major result of the new thing that no one had figured out yet. Like it didn't do anything even remotely close to that, right? It just, it happened to find a counterexample to a thing that, people probably weren't looking for the counterexample because no one thought it was false. That's really what happened. No human thought it was false. They're like, why would I write a code to try and look for a counterexample, Me and my colleagues look at finding counterexamples as just a search problem, not really an intelligence problem. Yeah, true. Let's see. What is the way to discover f of I and g of e and reveal it? You mean like break into Bob's computer and steal the function? Or I should say Alice's computer. Break into Alice's computer and steal her function? Like that's what you would do? Or do you mean how do you take the E and figure out the I when you're reading it, right? Well, that's literally the hacker's wet dream, right? I mean, how do you do that? Well, you do it through, one, you have to know what algorithm you're looking at, and two, you got to go through various tricks and things to try and figure it out, right? Most of the time, and this is the whole point of encryption, these end up landing on some type of required exhaustion, and the exhaustion is just unbelievable, right? Like it's supposed to be a billion things to try. And the point is that it will literally take you the lifetime of the universe to exhaust, right? And so that's the intention, is that the encryption algorithms intend that you would have to exhaust everything in the entire universe in order to reverse engineer the E to the I, right? Without knowing the F inverse, right? So most of the time you can't do that, so you have to try and figure out some trick to mess with the algorithm that no one else had thought of that might break it, faster. What is your thought on the Chinese book analogy with AI, where AI doesn't think how we do, but instead predicts the next best word? I'm not sure what you mean. So LLMs, they're trained on tokens, which are vectors of parts of words within speech, and then they figure out the relationship of those words, and then they prescribe it some type of interpretable meaning. AIs are then put together in sequence over and over again in various clever ways in order to try and make some type of generalized intelligence, right? So, like, for example, you build a thing that takes speech and turns it into images. So like someone says, I want a cat, and then it creates a cat image. So this means that it has to take the phrase, vectorize it, take that vectorized stuff, and then create the cat image from it based on its neural network understanding or whatever, right? Well, you can start chaining these together where you have that AI and you have another one that takes images and writes a description of what they do. And then when someone says, hey, I'd like a cartoon image of a cat or whatever, right? Or here's my cat Fluffy. Can you cartoonize cat Fluffy? It will literally sequence these AIs together. Like it'll take the image, turn it into text, take the text, put it back into the other AI, turn it into another image, take that image and compare it to the previous image and put that in a image combiner AI. It'll do all kinds of different steps to try to give you more cohesive interpretability and randomness through using multiple different AIs, right? So it's like the AI models we have now are typically dozens and dozens and dozens of AIs, right? That are all doing different things and different parts and whatnot. So it's quite complicated. Yeah. I think the AI was more patient than us, lol. The proof it gave was an example, which is the negation of the theorem, but I think we need to understand this could have been solved by other algorithms. Possibly, yeah. I don't know. I'll join again in the future. I've got to hit the hay, but your explanations are great. Yeah, thanks. No worries, man. Maybe one day we'll go over, RSA or something. I can go over that in detail if people like. Let's see. Mixture of experts. Yeah, I agree. Yeah. If you're new to the channel, just click the little, if you want to chat in the top, just click the little hand button, raise your hand, and then you can come up to the chat and we can chat with each other. So that's fine. Yeah. Oh, I got through all the questions. I get to take a sip. Need a little more coffee. I missed your question. I'm sorry. Can you break down and explain P versus NP problem in encryption? Oh. Yeah, well, that's a pain in the butt. Let's see. So does P versus NP break all encryption? I have to give that a thought. Hang on. I got to think about that for a second. So I don't think that that's the case. Encryption is above P versus NP. So even if you broke P versus NP, I'm not sure that would mean that it would break all encryption. I don't think that that's the case, right? Certainly I don't think it would break one-time keypad. It wouldn't be able to do that. One-time keypad wouldn't be able to be broken with it. So let's just make sure we understand P versus NP. Now, me personally, I think the best way to understand P versus NP is just to think about the my favorite problem, which is the oh my god, help me. It's a sorted unstructured search. Unstructured search. And so if you understand this one problem, you really understand the heart of P versus NP. It's this one problem, unstructured search. You can phrase P versus NP in a million different ways, but this is the big one, right? Unstructured search. So what is unstructured search? Unstructured search can be thought of as like a chip. So here's a chip, okay? And it's a computer chip, and it has inputs, okay? So it's got, 0, 1, 1, 0, 1, 0. Those inputs are going to go through a bunch of logic gates. So this is kind of like the circuit stuff that I was telling you about before, right? And so it does all these logic gates with the values, whatever, right? And then it outputs a 0 or a 1. So that's what it does. It takes in an input and it produces an output. So, and we would say it specifically, it takes in n inputs and it produces one output. The output is either a 0 or a 1. That's all it does. So that's a chip. So this might be considered what is called a binary chip or something. It just outputs a 0 or a 1, or we would call it, n to 1 chip or something. It doesn't really matter. So this is just the basics of what we're talking about. You can make any program you want that does this, right? And the question is, if you have such a chip and the chip outputs 1 only once. So chip outputs 1 only once. Then the question is, how do you find the one output? That's the entire question. How do I find the one output? How do I find the one output? So in other words, so I shouldn't say the output. What we mean by that is, how do I find the input that produces the one that gives 1, right? There's only one of them. So how would you do it, right? Well, the standard answer is you try every input. You just try them all. So if there's n inputs, there's 2 to the n. If there's n bits, I should say, n bits, then there's 2 to the n possible inputs. And so the way you find the one input is you just try them all. So just try them all. So this is one answer. So answer 1. Try them all. Right? And that answer is effectively a NP answer. It means that I had n inputs, but I had to do 2 to the n calculations in order to try to figure out the answer to the problem. So the P versus NP problem is literally the statement that answer 1 is a guaranteed requirement. That for any circuit, answer 1 is the best you can do, right? For any arbitrary circuit, answer 1 is the best you could do. So if I don't know any properties about the circuit, this is all I get to do. All I get to do is just try every input. That's it. And so that is the P versus NP problem. If you could demonstrate that an arbitrary circuit or just arbitrary circuits, the answer is there's guaranteed a requirement that you just have to try every input, then you would have proven that NP is strictly bigger than P, because you would have found an NP problem that cannot be solved in polynomial time. The other answer, which would be the people on the other side, they would argue that the circuitry magically allows some algorithm so that I don't have to try all of them. I don't have to try. Oops, can't see it. Have to try. And that would be if you demonstrated that. If you demonstrated that under an arbitrary circuit, right, then you could come up with an algorithm that's like, yo, if you have 5 AND gates and 3 OR gates and they're in this order, there's some thing you can do that will reduce it to this trick of this formula that will tell you what the input is that gives you the 1, then you would have proven P equals NP. And so that is what needs to be proven for P to equal NP, is you have to demonstrate for me, how do I take arbitrary circuitry and calculate out what input gives me the 1. If you could do that, then you would be able to prove P equals NP. Yep. Or you can try them all instantly. Yes. Let's see. What is training supposed to... Hi, your channel came across my feed one day. I struggle to understand the topics you discuss, but you break things down very well. Just want to say thanks. Oh yeah, thank you. Thanks for listening, watching, all that. That's cool. Thought on proving AI negation. We need to understand the problem, blah, blah, blah. Just got here. How are you doing tonight? Great. Things going good. Easy answer, hard question. Yes. Or you can try all of them. Yes. Let's see. It would break a lot of hardness assumptions. There is also the fact that P NP proof could feature massive exponents. It could, yes. So it could be, well, no. I mean, we don't know if P equals NP is able to be proven or shown or solved, right? It could be that it's not solvable or something, but no one's demonstrated that either. If you could demonstrate that, that would also be of interest, right? I'm just saying that this is what the P versus NP problem is. This is, in my opinion, the best way to explain it, is that you have a circuit, because so you think about a circuit as something simple, right? You even put a name on it. You consider it having like K circuitry. So that the K is supposed to be on par with N. So you can even make that restriction, and I think you would still have, like, it would be equivalent to the P versus NP. So you just pretend that you're only allowed to use N gates when you have N inputs. So you can use N gates, whatever gates you want, ands, ors, whatever, negations, doesn't really matter. The problem is just simply, how do you look at this circuitry and somehow do N calculations, 2 times N calculations, N squared calculations? You can do whatever calculations you want of these, but you want to do a polynomial's worth of calculations, which will be strictly faster than checking every possible input, because every possible input is 2 to the n. It's 2 to the 100, right? Like, imagine you have 100 inputs, 2 to the 100, right? So that's just, you can't check every possible input. And so try them all. If you could prove that try them all was what was the best answer for an arbitrary circuit, you would demonstrate that P is strictly less than NP, right? But if you want to be the person that's like, no, it just feels like there should be some trickery you could do with the circuitry. Like, because we can imagine trivial cases, like what if I just XOR all the inputs together? So I just have like one big fat gate that XORs them all together. Certainly, I'd be able to find an input that gives me the 1, right? Like, certainly there'd be a very easy way to do that, because I can see that they're all being XOR'd. So, like, there's a lot of people on this end simply because they could imagine many cases where I can easily see that I could do something faster than just checking every input, right? Like, I can see that that's possible. So why isn't it possible in general, And so, yeah, so if you could figure out answer 2, that means you have proven P equals NP. So this particular problem's NP hard. All NP hard problems are equivalent. If you solve any NP hard problem, it's equivalent to solving any other NP hard problem. So if you solved this problem, you would solve all NP hard problems, and so we would know the answer to the P equals NP problem, right? Let's see. No other. I more meant that a polynomial time algorithm doesn't automatically mean a fast algorithm. Yes, of course. Yeah, it could be a billion times n, right? Or a billion or a billion times n to the 100th power. Like, it could be an unbelievable amount of calculations required to mess around with the circuitry. But in general, we imagine that that's just a matter of making n bigger, right? Because if n now is 1,000,000 bits, then you have 2 to the million, and then you have 1,000,000 to the 100, and 1,000,000 to the 100 is clearly way smaller than 2 to the million, right? So, like, there's no this exponential checking, it just grows way faster than anything you could come up with as a polynomial. And so, yeah, everyone would be perfectly fine if you did, something truly clever has to be done in order for a polynomial algorithm to work, right? You have to be doing something truly clever, some clever way to get around the volume of checks that need to be done. There's got to be, you're reducing cases. This is the number of cases you've reduced it by more than just like half. You didn't just cut it in half or a quarter. You didn't just make it 10% smaller. You didn't do something like that. You did something truly clever where it's no longer an exponential search. It's now something truly clever, something much smaller than that. Yeah. What do you put in your coffee? Whatever my wife gives me. She decides. I like this axiomatic reasoning fella. Oh, thank you. Thank you. Yes. That's me. Oh, interesting. That's very fascinating. I've been recently working on mapping LWE to phase oscillators. LWE, that's the lattice things, right? The, what is it? Lowest something, something, I forget. Oh, learning with errors. Oh, I was way off. Never mind. I was thinking of shortest vectors. Shortest vectors. Yeah. Gap SVP. Gotcha. Yeah. LWE, learning with errors. Interesting. That's very fascinating. Yeah. Yeah, there's a whole industry. So if you go watch IBM's literature, they're advertising. They're like, quantum computers are going to be the next evolution in machine learning stuff. So everyone's trying to figure out how to get that shit to work together. You know, how do you use quantum calculations to make the AI compute even faster, you know, or train faster, right? Mm-hmm. Mm-hmm. Yep. Man, you know, in the comments all week, I get people that are like, yo, when are you streaming? I want to debate you. What's going on? You're wrong. You're just so wrong all the time. You're just a wrong person. And I'm like, okay, come chat with me. No problem. And then, like, no one shows up. I'm like, I don't know. It's actually quite the trivial mapping, since perfect integrate and fire neurons can perform linear integration. Oh, that's fascinating. I'm relearning how to use Python. Yeah, Python's good. All right, used to love logic. I'm now deck officer in the Merchant Navy on my way home to Scotland from the Antarctic, watching after a few beers. Cheers for sharing the knowledge, bro. Yeah, that sounds great. Yeah, certainly. So which side are you on? P equals NP or P not equal to NP? Yeah, you know, I'm probably at a P not equals NP. I mean, if P equaled NP, that would it isn't perfectly equivalent, but it's nearly equivalent. That if P equals NP, then quantum computers and classical computers are nearly identical. It's technically not true. You could technically have a difference between them, but like, having looked at quantum computers quite a bit, like, it's basically nearly identical. Like, if you actually solve P equals NP, that would just be a mind-blowing thing. That would just be completely insane. And it would probably mean that quantum computers and classical computers are basically the same thing. Oh, Jet wants to chat. Hey, Jet.
Hey, Bobby. Thank you, Bobby. This isn't really like, I guess, a debate. This is like just me going on a rant. What you said
Okay.
earlier, right? How you said that, oh, people want to debate you, like saying, oh, you're wrong about stuff here and there, blah, blah, blah.
Yeah, sure.
The thing that I don't like about debates nowadays is that, I mean, well, I'm going to start with my personal belief about debates. To me, I feel like debating is about when you have your calculation and your conclusion, right? And person B has your calculation and conclusions. Then you guys both come together and see where you guys make where you guys disagree, and then where you guys try to come up with a solution together, right? But
that's a reasonable debate.
debates,
That's a reasonable
yeah,
debate.
but yeah, exactly. But debates nowadays, to me, is like people, before people even start a debate, they already had their own conclusion, and they're not changing it whatsoever. It's like, I'm pretty sure that you kind of watch, some clips from I think from Jubilee, right? That's
Sure,
kind of going off right now.
Yeah. But people get exposed, right? Like Jordan Peterson was exposed pretty hard on like his
Yeah, he was.
hypocrisy. And I think that's like fantastic. Like, here's the thing. I don't want to go into the next election with another dumbass population where all these crazy mofos have been able to just spread misinformation and disinformation for decades and no one ever gave them any pushback. It's like, we need more smart people to enter into these dumb spaces and tell people, no, you're just wrong, right? Because that needs to be 24/7. Jordan Peterson shouldn't get to live down and be like, let me just sit over here and, never chat to anyone except my, Supreme followers or whatever, right?
Supreme followers, okay.
Like, we need exposure of this stupidity. We need to make, because I mean, I live in the United States, and it's like, I feel like, oh my God, the next few years, if not decade, are just completely hosed. They're the economy and shit. Like, we screwed up so much shit and it will take so long. And it's, I
feel like it would probably take like 30 decades. Not 30, 3 decades.
3 decades. And I think about the numbers of that, and I'm like, my frick, man. I had dreams. I was like, I'm thinking about, I'm gonna have a mansion one day. It's gonna be great. And it's like, well, screw all that. That's not happening. Like, instead, it's like, I have to deal with all this stupidity, and it's like, no, more people need to be talking with people and trying to make sure that there isn't these just spaces where like Phil bros can just go hang out and, lie to people 24/7. Like, no, this needs to be challenged and fixed, right? We got to tell people, that it's not okay to like, spread misinformation, disinformation. That's bad, right? How do I join the call from the Insta Live? So to join the call, you got to go to the Discord, and then in the Discord channel, the only channel with people on the mic is is this, right? I can make how do I do that? I click a thing, and then I click a copy link. Can I do that? And then I can paste it. Can I paste it? Okay, so there's the Discord link. So if you click that, that'll take you to the Discord, and you can join, and then you can join the link, and then when you're in the audience,
just talk.
Be like, raise your hand. You'll be like, hey, I'd like to chat, and be like, sure, no problem.
Yeah.
Have the floor.
You could talk. You could debate, or you could just go on a rant, like I am right now. But yeah, it's just I see that more often when people are just because I don't know, it's like debates today are like I'm not gonna. I agree with everything that you're saying. It's to be honest, what you're saying is true. We need more academics and people who actually know what they're talking about,
Mhm.
because it's like
Yeah.
it's like it's like you and me, right? We'll
Mhm.
both agree that that the Earth goes around the sun, right? And
Yes.
we may disagree about the speed, like how fast are we going, right? And then we
Mhm.
got person C is saying, no, the sun goes around the Earth, not the other way around.
Yeah.
And that's like, it takes us back a step back, because like, what? Okay,
Yeah.
now what the hell are you talking about?
I know. And yeah, I agree. Exactly. Yes, exactly. It's like just think of like the simple concepts of like, you know, the Republicans have tried to take a stance of, oh, the Civil Rights Act was a bad thing, right? And you have multiple people pushing this narrative, like who's the guy that does the state Empire cast or something? What's his name? Jesse Peterson. Um, and This is just crazy to me. This is just crazy. It's like, has
It's
no one
diabolical.
like no one has fucking sat and listened to like Martin Luther King Jr. speeches or like the interviews that he did with the news, like what are we talk like why are we going backwards, people? Like we figured this
Yeah.
shit out. This shit was figured out. It was already figured out. Why are we going backward? Like I don't get it. It doesn't make any sense to me. You know? I'm like, why? Like, and so we need more people pushing back on that. We can't just like let, Charlie
Yeah.
Kirk go from campus to campus to campus to campus, yelling at college students over and over again. And then like we have no one on the left that's like doing the same thing, I mean, until recent. Now you have like all kinds of left people trying to do stuff. And it's like, we need more of that because you can't just ignore these people. You ignore these people for 2 decades and they vote for, a freaking crazy person. And you're like, what? Like, how?
Yeah.
Like, I was in ignorance, right? I always thought, like, oh, well, everyone obviously goes and gets vaccines. I mean, it's like, obvious, like, maybe you have your like little conspiracies or there's like 3% of the population is a little wonky, it's like, okay, well, some people are uneducated, right? And then COVID hits and you start finding out just out of the woodworks, like you're like, well, just remember to get a vaccine, everyone. And you get like, fuck you, what the fuck? No, vaccines, they're putting microorganisms in your brain, and you're like, what? Like,
They're following us. They're following us.
this is, I know, you're like, I didn't even know that this was a political discussion. This is like, this is so benign. It's like the most, like, it's like, oh my lord,
It's beneath us, to be
insane.
honest.
I know
Yeah.
it's beneath us. Like they even put it in Marvel where like Captain America comes back and he's was frozen for like 100 years or whatever, and he has this list and it's like, what are all the things that like you're amazed by now that you're in the 20th century or whatever? And like in his list the top 3 was like, man, polio's gone. That's incredible. And it's because we people are not educated. They've never seen someone in polio. Like no one knows about the people that lived in iron lungs. Like
Yeah.
we're just completely oblivious to this shit. Like this is insane to me. Like yeah, I don't know. It's crazy. It's just
Yeah,
crazy.
it's so bad right now. And it's like,
Uh,
I think honestly, what kind of contributes to that, again, is the economy. Because how I say this, all right. So basically, when my mother and father, right, when they came to this country, to the United States, they see the country, right, the United States, as opportunity, education. Like NASA was like one of the most greatest breakthroughs that the United States ever built. Like that,
yeah.
like wowzers, right?
Yeah.
And you think about
Crazy,
that,
yeah.
right? Like it's crazy how this country, right, had NASA, and NASA did all these incredible things. So you would think like, wow, the United States is the smartest country on the planet, right?
Yeah.
Like there's no way they'll do anything that stupid, right? Or at least again, but and I think it's because it's just again how the United States became to be, because at one time, education where it was, was like a high priority, right?
Yeah.
But now it's like I don't even know, like the 6th, the 7th, or the 10th. Some people don't even think of it as a priority. Some people think of it as brainwashing now. It's like, what are you talking about?
I know.
It's it's just there's so many, like you said, there's so many pushback and setbacks, and it's like, what the hell? Like I feel like I feel like we were smarter back then, but that's not true. No, we know, we definitely are more knowledgeable now, but people like just don't care about the new education that we have now. So it's like they mostly care about profits, the money.
Yeah.
And I get that. I'm not saying that money doesn't matter. Money matters, of course it does.
Sure.
But
Sure.
if you put education like on last of the list, we're eventually going to get a setback. It's not maybe, we will.
Yeah.
And it's sad to see how this country is like descending. Cause don't get me wrong,
Yeah.
I have my critiques about the United States. I don't care what anyone says. I'm an American. I love the United States. You feel me? But
I feel you. Yeah. Me too. My
like,
country's my country, man.
Exactly.
We got to re-educate all these dumbass people. Like this,
But like,
I can't go anywhere.
What
am I gonna do? Go to another country? No, this is my country.
Yeah, exactly. And that's how I see it. I want to fix my country, right? But when you make a critique about your country, right, you got other people like saying, "Oh, just move, just go out." Why you? It's like saying like, "Oh, that a light bulb right in your house is busted," and you make a notice about that, and then I guess the landlord says, "Well, then just leave." Like, what are you talking about? Like, why would I leave? It's just a simple fix, but you don't want to fix it. So now it's like you're making a big argument when it shouldn't be a big argument. Like, why are we arguing about this?
Yeah.
Yeah.
I know. Yeah. And so, yeah, it's sad because it's like I thought that, stupidity was like a small thing, and that like I thought most people who are like, I'm really dumb, I don't know anything, so I'm going to defer to experts to tell me what, how stuff works, right? So the expert says, yo, get your polio vaccine, and I'm like, okay, let's do that, because like obviously that's good, right? I don't know shit, and if I had some fear, I would approach it from a rational point of view, like, hey, I want to ask questions like, what the shit does this thing do? How does it work? How does it, I want to know, right? But to then go to the polls and suddenly learn overnight, oh, actually 30% of the population is like just completely dumb motherfuckers. They're so dumb. And you're like, how did that happen? Like, we need more people talking in these spaces. We can't just let people have their, echo chambers where they're like, oh yeah, I don't know, what aboutism, same, all sides are the same. They're all exactly identical,
Oh, Lord.
Oh my God. It's like we gotta push back. We gotta talk to people. We gotta hold more meetings. We gotta do more stuff. Well, I got some questions. Let's see. Do you have any math tips for someone with ADHD? I mean, it depends. I don't know. There's ADHD could be incredibly helpful because annoyance and obsession with math problems can be really helpful as a mathematician. But there's a lot of you have to exist in the real world, and you want to be able to be gainfully employed later on, so you got to do other shit too. So it can be complicated. Have you heard of flock cameras against the Constitution? Flock cameras are like holy shit balls. How did that happen? Like, I can't believe that happened. That's insane to me. I don't know why flock cameras aren't like just like, they should just be federally banned. Like, we shouldn't have any flock cameras. What the shit?
I know, right? Flock cameras, like the whole premise of it is like, you hear, politicians like saying, "Oh, we don't want to become like China," right? With the whole surveillance, right? Then you got flock cameras, like,
Yeah.
bro, we all China now.
And I was
what's
like,
the difference now?
I'm like, what the shit? They can just type in a license plate and see all of your travel in the last 30 days, and it's considered perfectly legal? I'm like, excuse me. Here's the thing. As technology gets more and more complicated, thing aggregation and calculations go down, right? They become easier and easier and easier and easier. And so we need newer laws. Like, yes, we have a law of like you can record in public and that's allowed, right? But we then need to update it of like, well, no. The government isn't allowed to surveillance public places, for the purpose of tracking its own citizens. Like, we need an update on it that's not okay. You can't just, have private companies siphoning off public information and then sending it to the government for aggregation to spy on its own citizens. I don't. We have to not. We need laws in place. You can't have flock cameras. That's crazy to me.
Yeah, actually, one of my professors, back a couple of years ago, my professor was talking about that, right? Well, not about flock cameras, about technology and its advancements. He was talking about, like, sooner or later, the government is going to have to intervene with that because there's so many things and ethical problems that's going on with, AI and other advancements. And, it's like you said, it's like the law. It's like the law is not keeping up with the tech, and you got so many new things going on. Like again, I don't know how flock cameras is even legal. To be honest with you, that's like, what do you mean? Like they just follow you whenever and however, and you can't even say nothing about that. Like, I don't even know when it got into place. To be honest with you,
apparently it's been going on for years, and it's like people just started learning about it. Where they're like, wait a second. Everywhere I've been for the last 30 days.
Yeah.
How the fuck would you know that? You put a tracker on my car? Nope. Like, here's the thing. Police put a tracker on your car. That requires a warrant. It requires a warrant to put a tracker on your car. How the hell would it not also require a warrant to purchase all the data necessary to do the equivalent of a tracker on your car? Like, just because you change the medium doesn't mean it shouldn't still require a warrant. That it makes no sense, right?
Yeah, it's basically they changed the recipe, but it's still end up the same meal.
It gets the same results. It's the result that needs to be banned, not how you did it. Let's see. Just wanted to ask if you think people should stop saying math is spiritual. I don't know. I truly don't believe math can be spiritual. Yeah, I probably agree. I hope that contributes to your thinking in this thread here. I totally agree. In general, I'm fine using words in poetic ways. So like, I have no problem being like spiritual or this or that. Like, I think that's fine. If anything, I get upset that that's like taken by other people. Like those are words that have, meaning to humans, right? And they don't necessarily have anything to do with like a religiosity or something. Let's see. In your opinion, what makes someone an idiot rather than simply uninformed? Oh, that's a tough one. We need to get better at diagnosing willful ignorance, because willful ignorance is so detrimental and hurtful, right? And so we need to get better at calling people out on their willful ignorance instead of just like, oh, okay, you just don't know anything, There's just some stuff that's just blatant, What is, I think one sign that really demonstrates that is when you find out someone has an incredibly strong opinion on one side of an issue, but they have no idea about the issue. This is a demonstration of like willful ignorance because they hold one side, but they've never even looked into the other side. Like they've never looked into anything. Like they don't even know why they hold that opinion, right? Oh, geez, this died. Hang on, discard video. Unlike a year ago, stupidity was fringe. I mean, EO 12 blah blah blah. EO 12333 is for foreign surveillance. That doesn't allow you to surveil inside of the United States borders. Live video. 3 public. Click button. Clicky thing. Click this thing. Click. Click. I should say that's what I thought, but I don't know. I could be wrong. URL YouTube done, confirm, go live. Boop. I say, it seems once people got word of it, there has been a mass local pushback and no renewal of contracts, which is good. Yeah. However, there needs to be some serious legal consequences for putting these things in. Yeah, I agree. Yeah, it's freaking crazy. There was something similar to E12333 in World War II, where all phone calls went to NSA predecessor AFSA, and then the wire tapped all of them until 79. Yes, well, so phones, remember, phones go all the way back to 1890, right? So phones have been around for 135 years. So phones, phone lines, telephone lines, blah, blah, blah. And for a huge amount of that, they were completely unencrypted. Like someone could just put a device on a line and then they could listen to it. Now, way back when, like in the 1910s and 20s or whatever, phone lines were literally like fucking 40 volt, cables strapped up, in the thing. And like they were basically running electrical lines, and you could get electrocuted on those suckers, and they were just doing phone calls, right? But they didn't know the technology and all that, and so it's obviously improved, right? Now phone lines don't electrocute you. It's the electrical lines that electrocute you. But way back when, it was phone line could do some serious damage. Anyway, the point is that there's even like Bonnie and Clyde and whatnot. They would tap phone lines so they could listen in on phone lines and do stuff like that. The government did all kinds of stuff. So it was like there was all this weird nuance because like no one knew like what the rule should be. Like, well, the line, it isn't owned by or it's owned by the phone company. So like if the phone company says you can just listen to it, then are you allowed to listen to it? Like there were weird complications like that. And in the 1970s and stuff, right, the government heavily engaged in all kinds of stuff that was like, nefarious, doing this and that. I have no doubt they were probably doing shit against, our own citizens. I mean, shit. Martin Luther King Jr. was declared a domestic terrorist, right? By multiple different states and counties. And they were doing, surveillance and investigation of him repeatedly, right? Nowadays, though, things are quite a bit different. There's a lot more laws and there's a lot more distribution of power, right? So you have things a lot more defined. You actually have things like EO 12333 or things like FISA warrants, right? Like these things exist, meaning that if you don't do them correctly, then you're not allowed to do the particular act. And so we can say, well, maybe it's not good enough, or maybe it was, maybe it needs to be better, or it needs to be refined, or it needs to be updated, whatever, fine, right? But the point is that those things exist, right? Whereas like way back when, they just didn't even exist. There was no such thing, right? There was no, whatever, right? Let's see. People do stupid things. devil's advocate, if citizens use Flock on their property and they share it with other Flock users, that's legal. Yes, gaining access to those images is based on those agreements. People do stupid things. I know. See, this is where it gets a little tricky. So this is why it needs the laws need to be specific to the government, because like as a private investigator, right, you're allowed to follow around anyone you want. You can go to any public place, you can look at people, you can take pictures, you can do whatever the fuck you want. You're a private investigator. You're a citizen, you're allowed to do whatever you want, right? The government doing certain actions has restrictions. The government cannot just do whatever they want. And so the government, even if people were to sell their data to Flock companies and the Flock company was to aggregate the data, it should be 100% illegal for the government to purchase that data without a warrant, right? Because it's equivalent to doing those things that require a warrant. So the government can't have access to those things. That's just not okay. Now, if we make it like, well, what's the difference between the government seeing those things and the government, not seeing those things? Like, where's the breakdown? Like, this is all stuff that needs to be litigated and figured out. I think it would just be easier to make a law that's like companies are not allowed to aggregate data for the specific purpose of spying on its own citizens. That should just not be okay. So if you make it illegal for companies to do that, they wouldn't be purchasing people's data for, a Flock system, right? Whenever you have a contract agreement with a company, you agree to their rules and what they share. Example, you get a credit card from a company X. Yeah, but we can change that shit, man. We can make a law. That's hang on. That's literally why if someone steals your credit card and they use it and you call the company and you're like, yo, I didn't do that, right? You're not liable. Well, guess what made it to where you weren't liable? That's called the Consumer Protection Act, right? Or whatever it's called. It's the Consumer Act, right? We made that a law because we saw the ramifications it was going to have. We made it the responsibility of the credit card companies to fix their shit. They need to implement better stuff. They need to make sure that their cards aren't being, sold or stolen or whatever. They need to do that crap. You can't make the consumers deal with fraudulent cards or shit. That's crazy, right? And so the point is that we made it a law that it's their responsibility. It's not the consumer's responsibility. So the point is that we can do the same thing, right? We can make laws that like, hey, no company is allowed to sell your data or aggregate your data for the express purpose of, doing things that would, or aggregating data that would have required a warrant in the first place, right? And so then it becomes the company's responsibility that they got to get your, written, wet signature notarized. Like we could just make it that law, like notarized signature that was written on a piece of paper with an actual pen. And then you can collect someone's data as a company. But if you don't have that shit, you can't do it, And you just put the onus on the company. You don't make them. You don't let it be the other way, where like they can just make whatever agreement they want and just stick it on a little thing like I accept, and then you have to click the button. Like we can change the rules however we want. We're the voters. Voters can make whatever rules they want, man. They share them in company XY, and you agree to that. If you don't, just cancel the credit card. Yeah. The other point I was making is that people share their data, so in many ways without their knowledge. Yeah, so there is even more complicated stuff, right? Because what's another example that comes to mind? Many people have done like 23andMe and these other like DNA companies, right? And in those companies, they don't need everyone. They only need a statistically significant percentage. And that allows them to track the relationship of everyone. So, multiple times at this point, the government has taken cold cases ran it against that database, which then pinpointed them to some small group, right? And then they went through that small group and investigated everyone in that family tree and tried to rule out, age, height, age at time of crime, blah, blah, blah. And they literally boil it down to like 4 or 5 people. And then they spend a few months, investigating those people. What are their habits? Where do they go? What's going on? What is it that they've done? Where have they been? Right? And suddenly they've solved a number of cold cases at this point. So a number of cold cases have been solved, finding people that never even did 23andMe. They didn't even do it. And they got found because of the 23andMe database, right? Now, I have a broken opinion here, because on the one hand, we're talking about horrible crimes, and I am so happy that they've been solved, right? But on the other hand, I'm like creeped out, right? And so it's like it's a double. I'm broken on the issue. I don't know which side I want to be on, because it's like I kind of like every single person volunteered their data, so it wasn't like, like, should they be allowed to look up? I like those crimes being solved. That kind of, that makes me feel safer. I like all those crimes being solved. I don't know. That's a hard one, right? Let's see. This is what actually led to the fight. This is so funny. I meant that they are calling a lot of groups like Antifa as domestic terrorists nowadays as well. Yeah, they are. It's Trump calls literally every Democrat a domestic terrorist, radical, lunatic, crazy, moron, whatever, right? So they just go out of the woodworks, right? So I don't know. If you just came in the Discord, FYI, just click the raise hand button. If you want to come up to the chat, you can chat and say hi, whatnot. The other people to point.
Hey, I was gonna say
Oh yeah.
about about the comment before, the which is how can you tell someone's dumb, an idiot, or uninformed?
Mm-mm.
I would say it kind of depends. Like, for example, right, when it comes to I guess it's kind of what Jubilee talking about, right? Like about systematic racism, at least in the United States, right? I understand how some people would not know about systematic racism about in today's age, even though I cannot find it hard to believe. But I give people the benefit of the doubt, like,
Sure.
how systematic racism, does that exist or not? How do you know? There's one thing knowing that it exists, and then there's knowing that it exists in a way, but you reject it. Like, for example, right? According to, I guess, the FBI statistics, I think when it comes to like violent crimes, Black people are 8 times falsely convicted of it. Like, like,
Yeah.
I don't know if that tells you like what does that mean to you? Like, if it was like maybe 2 times or 3 times, okay, that's all right. That could be somewhat more understandable. But 8 times falsely convicted,
Yeah.
and that's what the FBI found. That's not that's not like the exact proof. That's just what we got so far. So it could even be more than that, because again, there's some I guess falsely convicted Black people in prison that's passed away, or they haven't spoke up about it. Who knows? But that's just what the data has said. So that is already evidence of systematic racism. Now, for what I've known, some people don't even know about that. So it's like sometimes I'll tell that to someone's debating me or tell me that, per capita here and the bullshit, right? And I would tell them, okay, well, per capita, Black people 8 times, blase, blase. And they're like, what do you mean? I'm like, what do you mean? What do you mean? It's really in the same day. Like, I'm like, where do you get that statistic from? the same statistic you got your statistics from. Like, what are you talking about?
I
Like,
know.
oh, yeah, exactly. It's like, and then tell me, oh, I didn't see it, and I'm like, I don't know, maybe it's in the next page because it's there. Like, you know. But so many people that will either reject it, and those who reject it, those are the ones that I would like. I don't know, call like you said, willful ignorance.
Yeah.
Like how it's like I don't understand how you're going to use the same data that you're saying that is true, but then reject the other data that was made from the same person just because it makes your
Yeah.
point pointless. I don't know.
Yeah. Yeah.
It's
No.
it's
Yeah. People rationalize things, and that they need to be pushed in forums so that they're not just oh, that thing that I keep thinking over and over again, no one has ever told me sounds a little racist, right? And it's like, how do you go 15 years, 20 years and you're never told, yo, that idea is pretty racist, man? And it's like, I don't know, like people need to um we need more people pushing back on people, right? Like we can't just we can't live in this craziness, right? Imagine a call from your landlord in the middle of D-Day. Yeah, that would suck on like many levels. um yeah, you're making me think of like Charlie Kirk, who would he would abuse stats all the time. I remember a paper that he did where the paper was about the wage disparity between men and women in the same jobs, right? They're doing the same jobs with the same work, right? And they went through and calculated it, and they had thousands of people, and they had to equate them on their experience and all this stuff, make it like equal person, same position or whatever, right? And the calculation came out to I forget what it was. It was like 86 cents or something. So the difference between the means was about 80 cents, we'll say, right? And
okay.
Charlie Kirk would come out of the thing and be like, yeah, this paper says the difference is 80 cents. Does that sound significant to you? And he would just like berate students who didn't know stats, right? And I'm like, I'm listening to this video and I'm like, this guy is like being a freaking what a deceptive little piece of shit. Like he doesn't know anything about how this works, like he doesn't know that, like, and here's the thing that's missing, right? He doesn't know the difference between an aggregate mean versus a individual case. Like if you find a woman and a man and they have the same job, same position, whatever, and the woman makes 82 cents less than the man, then you would say, well, what is that significant? And it'd probably be like, well, no, it's not really that significant. One person's at 15 an hour, someone else at 16 an hour, right? You're like, I don't know, things, it just randomly went one way or the other, right? That isn't what the paper presented. The paper presented an aggregate mean over like tens of thousands of people. So I just want to imagine for a second that you enter into a company and the company says, hey, we pay 16 an hour. And then they look at you and go, oh, but you're a woman. And we always, 99% of the time, pay our women 82 cents less, right? And they make you, they have you sign a contract. You will pay 82 cents less, right? That's a different statement because, like, in my mind, would you even give a shit if it was 82 cents or 1 penny? Like, if it was 1 penny and you were told, oh, there's a 99% chance you will be making exactly 1 less penny because of your gender, right? Like, that's a radically different statement than, oh, I just met a man and a woman and they have a difference in pay. Like, it's just a radically different statement. Like, if you pick a random woman in this company, there's a 99% chance that they will be making 82 cents less than their counterpart with the same experience and the same title, you know? Like, that is crazy that he would conflate those together. And so anyway, so someone like him is clearly a misinformation person. Like, he actively tried to lie to people about what the numbers meant, how to read them, you know. I find that incredibly disheartening. Yeah. Mind if you show my analysis notes of possibly I had a question surrounding it? Sure, we can talk about math. You wanna do the hand raise thing? Come up, or did you want to just chat in the side chat? Where does crime exist? It all depends on where you look. That's true. Yeah, there's a problem of over policing in various areas. You know, but there's other problems too, right? You know, poor people are more likely to commit crimes. Um, you know, there's various other systemic things that have come about. Discrepancy is more likely to cause crimes as well. Like, if one particular group is like suppressed and prevented from having opportunities or whatever, then even if their opportunities are far better than, you know, let's say people that lived in the 18, you know, 70s or something, right? It's still that just does you know, does a bunch, right? Okay, so the maximum modulus principle. Hang on, let me. How do I? Can I do that? And then. Put it here. And go here. Go here. Go there. Okay. Well, so I gotta go here. Okay. Then I gotta go.
Hey, you could invite Zeno if he wants to come in.
Yeah. If Zeno wants to come up, sorry, Zeno. What do you put in your coffee? I know. Whatever my wife gives me. That was my answer. So she determines my health. Um, maximum principle. So we prove by contradiction. So the maximum mantra is suppose f is not bounded. Thus, for every m there exists an element a, such that if fx is greater than this in particular for every n. Suppose f is not bounded. Thus, for every m in AB, is there a real maximum modulus principle? I don't think there is a maximum modulus principle for real valued functions. Thus, for every m, there exists an element such that f of x is greater than or equal to m. In particular, for every n, the set this. By the axiom of choice, we can choose an xn such that this. Oh, that's not the axiom of choice. Okay. Yeah, okay. So there's some stuff you're missing here. So that's not the axiom of choice. So there was no need for that. Such that f of xn is greater than or equal to n for all n. Oh, maybe it is the axiom of choice because you have that condition. This sequence lies in AB, in this way theorem, this subsequence which converges to L, increasing sequence in particular, we see AN, since F is continuous at AB, continuous at L, in particular we see the limit is L conversion, hence on the other hand we know constant junction is this, and hence this is not bounded. Thus by the maximum minima, let F be a function, F attains its maximum at x0, if we have this and this. F attains its minimum at x0 if we have this. I'm not sure what you're So that's the definition of maxima and minima. But that's what's your statement for the maximum modulus principle? So the maximum modulus principle is only for complex valued functions. So normally the statement, the maximum modulus principle, means that a analytic function achieves its maximum on the boundary, meaning it can't obtain it in the interior. But for real valued functions, that's certainly false. I can easily give you functions in which the maximum is obtained in the interval and not on the boundary, right? And so we need to get the exact statement of what you mean, because in general there is no maximum modulus principle for real valued functions. You have to be a complex analytic function to have the maximum modulus principle. Gotcha. Yeah, give me the statement of what it is that you're trying to prove for 9.6, and then I can look at it a little more. Let's see. Anyone else say something? Message got retracted. Oh, I'm sorry. YouTube did an automatic retraction thing. I don't know. You might have said a cuss word or something. Maybe it got upset. Did anyone say anything in here? No one said anything on Instagram. Okay. Cool.
The comment we were saying earlier about how I guess Charlie Kirk will go to campuses here and there and speak to students. What I don't understand, well, maybe is I guess I'm giving people too much credit, right?
Mm-hmm.
Is that when you speak to college students, right, especially like freshmen or sophomores, they're not like, it's like when people would say like, oh, he's smarter than college students, so college is like a waste of time, right?
Mm-hmm.
I'm like, you're speaking to freshers and sophomores. I'm not saying that they're dumb, right? But they're students. They're
Yes.
literally learning. They're learning about what's being talked about now. So like, it's like you said earlier, not every student is gonna understand statistics.
Mm-hmm.
Now let's say if he were to like talk to someone like a master's student, like a graduate, like a master's like myself, or a PhD like you, or even professor like you also used to be, then okay, that would be interesting enough. But I don't understand how you go to campuses and he's like, well, how old is he? Well, he was like what, in his like mid-30s, and he's talking to like practically kids like what, 17, 18, 19, like
well, and he did more than that. He also had a podcast, his own podcast, and he would but the main thing is that he did these extreme views, right? And then the GOP saw an opportunity to spread misinformation and disinformation to screw with people. And so they literally promoted people like him. Like he was paid like $25 million by the GOP to continue doing his work of spreading lies about like Martin Luther King Jr. and stuff. And it's like, that's just crazy. That's so crazy.
Yeah, it's diabolical.
Yeah, it truly is. Yeah. Let's see. Hang on. Lemma, let AB be in the reals and F map AB to R be a continuous function on AB. Then F is a bounded function. Ah, yes. Okay, yes. So, yeah. So let's be clear. The statement maximum modulus principle or maximum principle or something along those lines, that generally would mean that you achieve your maximum on the boundary. That's what that normally means, right? So here, there's no statement that you achieve a maximum on the boundary. There's simply a statement that you achieve that you're a bounded function. So a bounded function means that the range is bounded, right? Another way to say that is that the image is closed, right? Doesn't it? Does it have to be closed? Hang on, I gotta think about that. If you're continuous, yeah. So I think that's right. If you're continuous, do you have to? You have to achieve a maximum somewhere in the interval, or a minimum somewhere in the interval. If you're continuous on AB and AB is closed, right? So generally this is proven, I thought, a little easier, but maybe I'm wrong. Suppose, for the sake of contradiction, f is bounded, thus not bounded. Thus, for every number m, there exists an x such that f of x is greater than or equal to m. Yes, so there exists an element x. In particular, for every natural number x, as it goes from here, so this is a non-empty set. Thus, we can choose a sequence such that this, and yes, that would be the axiom of choice. Okay, so I see. So you're right on the axiom of choice. So the thing is that there's a sequence of non-empty sets being defined, and that's what the axiom of choice is defined on. So a sequence of non-empty sets means you can choose an element from each set without knowing anything about the element to choose. And that's what the axiom of choice says, right? So the sequence lies in A, B, and so there exists a subsequence which converges to some point L, where this is this. And in the sequence this, and in particular, this is greater than this, y, use induction. Since f is continuous in AB, it is continuous at L, and in particular, we see that the limit is f of L. Thus, the sequence this is convergent, and hence it is bounded. On the other hand, we know from the construction that this is greater than or equal to n greater than j, and hence if c is not bounded, a contradiction. Ah, I see. Okay. Is that required? Isn't there? I thought there was a simpler proof to you achieve a maximum in the interval, right? Why would we think you don't achieve a maximum? If Yeah, I guess he would have to do something like that. Huh. Alright. Yeah, no, that's fine.
Which math class does this fall in?
This is real analysis. So real analysis is the foundations of limits and integrals and those types of things. You may encounter a rather different maximum principle in complex analysis involving the analytic functions, harmonic, those maximum principles not directly related to this one, and blah, 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 blah. Yes, correct. Yes. Yes, so in general, when you say the phrase maximum principle or maximum modulus principle, people think you mean, oh, you can only achieve your maximums on the boundary. But for real valued functions, that's not true. You can achieve your maximums not on the boundary. So they don't satisfy the maximum modulus principle. Analytic functions, though, in the complex plane do. All of their maximums must be achieved on the boundary. They cannot achieve them on the interior. Yeah. Sorry, I had to restart browser. No worries. Your message got retracted. I don't know if that's like... Can I unretract it? Will it let me? I don't know. It won't let me, man. I don't know. So you gotta message me in Discord or something. You can put all the cuss words you want in Discord. That's fine. Like f of x equals negative x squared on negative 1 to 1. Yep, exactly. Yes, correct. That achieves a maximum. Yes. I thought there was a slightly easier proof. The whole subsequence thing sounds like a pain in the ass. Is there an easier proof? Like, because you have like the intermediate value theorem, right? How do you not? Isn't there like an intermediate value theorem? Like, if you know the intermediate value theorem, can you get can you prove that you get a maximum, and if you're continuous? What would you do? You say, okay, well, let so the first one achieves a boundary, and then the next one yeah, I guess you got to do it this way. You know what I think it is? I think I've seen this proof modified that rather than it being done this way, you instead do it from left to right. So you define your intervals going from left to right and getting bigger and bigger as they go to the other side. And you basically do an argument, if I remember correctly, like, okay, the first interval only has 1 point in it, so it clearly achieves a maximum. So there's a maximum there. And then you say, okay, well, if they all achieve a maximum, right, as you get bigger and bigger, then you should be able to demonstrate that because of continuity, you know that as you take the limit as you go to the right, it's got to be b, or f of b, whatever f of b is. And so those maximums have to achieve a boundary somewhere, because they converge to f of b, right? Like every possible sequence you can take from left to right has to have a maximum point. So I think in my head I'm just recalling that it involves some type of left to right calculation, but I don't know. I don't remember off the top of my head. I'd have to look it up. Tao likes to do proof by contradiction. That's probably why. Oh, everyone likes to do proof by contradiction. In fact, there's a whole society of the whoever they are, the people that don't like the proof by contradiction shit, and they're still stuck on like the intermediate value theorem. Like, no one knows. I believe that that's the case. No one knows how to prove the intermediate value theorem without proof by contradiction. And so, like, if you don't allow proof by contradiction, calculus is like just stuck. There's you don't get anything in calculus. Intermediate value theorem's the next section. Really? Oh, that's fascinating. Huh. Thought it was proven a little earlier. Let me see. Blah, 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 blah. There exists C such as this. Yep. Yeah, that's true. Yep. Sorry, had to restart browser. Why? Any other questions or anything? Oh, I got a message in Discord. Message me in Discord. General casual. I'm assuming axiomatic reasoning has addressed Gödel's ontological argument. If he has, can anyone send me the video of it? I don't know if I have. Maybe. You gotta tell me. I'll be realistic with you. Either one will be fine. Blah, blah, blah. Oh, okay. That's someone chatting with someone else. Second hardest thing you've ever had to lecture. My second hardest thing I've ever had to do a lecture on? I don't even know what the first hardest thing is. What's the first hardest thing? Normally when you go to do a lecture, you're well equipped with knowing how the shit works, because you have to, you got to prep that, like, people are going to ask you every possible question. You have no idea what they're going to ask you, So it'd be very weird to be like, oh, I'm not ready to give this lecture or something. That would be very weird. Huh. I also like how the next chapter on differentiation is shorter than this chapter, which covers continuity and subsets of the real line. Yeah, yeah, differentiation. Well, differentiation's another limit. It's just the definition of a limit. Um, you know, once you get limits down, you know, everything starts becoming a limit. A limit. Well, surely there's a subject. I don't know. I've only ever given lectures on math. Maybe presentations I've given at work. I've had a few presentations with like, you know, a customer where I'm nervous as shit. You know, you got to put on the tie and cut your hair, maybe shave a little. Okay, I don't know. Those are scary. A professor, I don't know. You get used to being a professor. Maybe the first lectures I ever gave, certainly when I was like first being a teacher, those are probably more nerve wracking. But after your 10th class that you've taught or whatever, it's like you're just doing the same thing over and over again.
It's just again like little rant. I
Mhm.
just find it fascinating as sometimes I take a look. Like right now, I'm looking at what you guys are talking about, and
Mhm.
I'm not going to say that I'm an expert in real analysis, but again, I won't say I finished every single math, but my last math was differential equations and linear algebra. So of course I took calculus 1, 2, and 3, and all that. So I'm looking at what's being written, right, and I can make up and understand what's being said, right?
Mhm.
But sometimes it's like I'm looking at it, I'm like, okay, I kind of understand what's going on here and there. I understand what he's talking about. I understand what you mean, the axioms and everything.
Yeah. Yeah.
But at the same time, I'm like, math is basically like a language in itself. Like I'm pretty sure like 90% of people will look at this and be like, what the hell is going on? like, like, what does this mean? This is like, what is this? Magic, witchcraft. And it's like
Mhm.
it's interesting because like I'm looking at it and it is in a way like a language in itself because like you got to understand calculus, you got to understand calculus, you got to understand algebra, some geometry
Yeah.
here and
Yeah.
there.
Yeah.
It's interesting. It's like a step back. Like,
Mhm.
this could be very complicated for people.
Yeah. It can.
And
It can be. Yeah.
yeah,
Yeah. Yeah. Sam Guini, if you want to chat, just raise your hand and I can bring you up to the front. That's fine. Oh, hey, sure. All right, I'm gonna let you go, Jet.
okay, see ya.
Hey,
Hello.
Sam, how's it going? Did you have any questions or anything? Something you want to chat about?
Good, yeah. And by the way, it's nice to meet you. I enjoy your videos, even though I am not a mathematician at all.
Well, thank you. I appreciate that. That's awesome. Yeah, this
Um,
whole thing's kind of new. I didn't expect it to go so big so quickly. So this is kind of all surprising to me.
yeah, it's cool. I found you because of that Instagram video that went viral where you were absolutely trashing on this kid with the Hamilton book.
I
So
know. I'm so sorry. I'm like,
yeah.
geez, I need to like find him and be like, yo, man, that was
Yeah.
amazing. Yeah.
Yeah.
So
No, it was a good conversation though. Yeah.
yeah, yeah.
But yeah, I'm not super experienced with mathematics like everybody else in this server. I'll be totally honest. I'm a complete noob.
Oh, no
I'm in
worries.
STEM though. I study neuroscience and I really like physics and I've taken just physics classes. So that's really like as far as my math experience goes. But
Sure, sure.
it has shown me like the world of like mathematical reasoning, how like Jet previously was saying that it is a language itself. You can use it to sort
Mm-hmm,
of
mm-hmm.
speak logic into existence. And it really is like beautiful and magical and amazing. But
Yeah.
Yeah, I just want to know your thoughts on more like on more narrative focused research. Like I have a lot of respect for the anthropologists in my university and some of the work of theirs that I read. It's not a very you definitely wouldn't call it axiomatic, I guess you would
Mm-hmm.
say. So I just want to
Sure,
know
sure.
what your thoughts on that are.
On like anthropology or like
Yeah, on like
general.
ethnographies, like narrative sort of research that gets published in the same
Mhm.
journals as more like empirical papers.
Yeah, I think that's fine. I think it's fascinating. I defer to those people's expertise. Like when I want to know about anthropology stuff, I'm going to go to, anthropologists, right? People are trying to understand things, with sound reasoning. Typically, when it's something like anthropology or, more of the biology sciences and whatnot, typically it's a little more like applying particular formulas, because those kind of govern how things work. There isn't so much like calculating things per se, right? Um, there's, I mean, I don't know. Maybe I should not be so harsh or whatever. Not saying that that's harsh, but the point is like there's a lot of useful things, questions to answer that utilize like basic mathematical principles, right? And those things are not just answered simply because the math exists. It still requires people to get in the weeds and take the soil samples and figure out, how the world actually works, right? And so, I truly appreciate people that are willing to do that work. Um, yeah, when I was debating Kent Hovind, I went over the whole dendrochronology people. I'm like, these people, they exist, Kent. Like,
Yeah,
what
that
do you
was
what
a
do you
really
think?
crazy debate.
I know. I'm like, these people exist, right? Like, what do you think? Like, I showed him the photo. I'm like, look it. Here's the conference. You got like 100 PhD people here, and he's like, oh well, they're all being paid by the government, and I'm like, of Zambia, like, and he was like, well, maybe not Zambia. It's like, I mean, come on, man. Like, what? Like, you're making it out like no one has an interest in tree rings except you, who like it literally cites their papers, and then forgets to mention that there's annual rings versus seasonal rings. Like, I don't know, just kind of depressing.
Yeah.
But
It was
yeah,
actually that video that introduced me to the tree ring community. It was really, really interesting stuff. Yeah. But to
yeah,
get
yeah.
to the bottom of the initial question, I've been
Hmm.
reading this book by like legendary neurobiologist. His name is Robert Sapolsky. And
Okay.
he had this kind of, I don't know if it's a hot take in the community. I'm still an undergrad.
Hmm.
So I'm just still definitely only dipping my toes in the world of academia. But he said that
Hmm.
although he's a biologist and he firmly believes in like, we don't have free will, there's no room to shoehorn it in and stuff like that, that
Okay.
you could never make an argument that as a molecular fundamentalist that it's just going to one day like consume the social sciences and ethnographies and stuff like that. And I just found that interesting that even though he's like such a strong determinist thinker, he still has that sort of take. And I just want to know what you think about that. Do you think it will consume it one day?
Um, Wait, I'm sorry. You're gonna have to restate the last part again. Something
Yeah,
consume
sorry. I mean,
something.
it's kind of an assumption. I'm assuming that you are sort of like a materialist, molecular
Probably,
fundamentalist,
yeah.
mathematical guy. I mean, it's in the name, axiomatic reasoning, right?
Yeah,
So,
yeah,
like, do
yeah,
you
yeah.
think that one day it's going to gobble up this sort of narrative approach at research, and like social psychology, and one day it is going to just be like
Mm,
like the fundamental molecular level of everything?
no, no, there's no way. So the um, complexity. So so things get broken down at different levels. Like we break down things at the molecular level, but then we also take groups of atoms and we break those down at a higher level, right? So like when we refer to a chair, we mean an assembly of atoms in a particular order, right? Or we refer to something else and we mean a, you know, whatever. There's just no way that that these things are going to go away. The only way these things would go away is if our brain capacity somehow exponentiated in size and we had the ability to operate on all these different levels at the same time. We require summarized categories, and in particular we require analysis at the summarized categories. And so we're never going to like get away from the approximatory probability calculations that we do at the statistics and anthropology and biology levels. Like those are just never going to go away, right? It doesn't seem like it to me anyway, you know.
Even with the rise of AI.
No, I just no, because AI, you know, yeah, if anything, AI has to still summarize it for us. What good's an AI if it can't tell us what it's thinking, right? It's got to tell us. It's got to tell us what it's doing, and so and this isn't even taking into consideration that there might actually be fundamental like quantum barriers that prevent us from having any type of certainty in our calculations, right? And so that may actually be a thing, that it isn't, you know, it is not possible to know the answer of something given enough information, right? That may just be a fundamental barrier to us, right? But besides that, right? Summary information is just simply a requirement for human brains, right? Like, you know who said this? Brian Greene, I think it was, right? On one of the, he does the, he's the physicist that does the, what is that called? What's the thing called? The thing? Oh, you have a pushback on the quantum statement. I know. Oh, I'm sorry. Bobbin wants to tell me that I'm wrong on the physics stuff.
Okay.
Hang on real quick. Okay. All right, Bobbin, what did I say wrong?
Okay, can you hear me?
Yeah, I can hear you.
Yeah, I want to. Maybe I misunderstood your point, but if you want to, you know, make the statement that you know, there's quantum barriers to what we can sort of, I guess, understand. You can still quantify what the quantum mechanics says about what you can understand. So you can apply a probability to this possibly this case, and we understand that well.
Yes, I don't disagree. But that doesn't give us certainty on what the outcome of something would be, right? So like this is what I'm pushing back on, is a qubit could be in a superposition of 0 and 1, okay? We model that as 50-50. Now, there's two outcomes. It could be the case we don't know if it's a 0 or a 1, or it could be the case that it literally is both a 0 and a 1, right? And those are two different statements, right? One is just simply about not knowing, meaning that if we had enough calculations about other things around this, theoretically we might have been able to figure out if it was going to be a 0 or a 1 before we measured it, right? But the other one literally ascribes a barrier of knowledge that it is not possible for you to know a priori, no matter how much more information I give you. You could literally know everything in the entire universe. You still don't know if it's going to measure to a 0 or 1. There's nothing that will allow you to figure that out, right?
Yeah. The point I was going to say is, you can, what you just said right there. You could say it's probably going to be a 0 or 1. You know.
Yeah, you can say probably.
That's my point.
You can calculate it. You can be like, this is a 50-50, 0 or 1, right? We literally build chips out of it, by the way. You can buy physical cards you plug in, and they do quantum mechanic, you know, random.
I worked with those. They're cool.
Yeah, like quantum mechanical random variables rather than like system random variables, right?
Yep. Yeah. That's my point. You can kick me out again.
No worries. Thanks for letting me know. Keeping me honest.
Yeah, thank you for clarifying. Thank you. Yeah. So then would you say then that that because the way that I learn statistics is like, oh, this is a math that was invented for humans to better understand the world. But
Mhm.
if that's the case, if there are really these like hard quantum barriers, would you say that statistics and probability is like just a fundamental aspect of the universe?
I mean, maybe. So maybe we're getting a little bit too nuanced here, but there's technically a
Sorry, I
separation.
like philosophy.
Oh, no, 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 no. Hey, you have no requirement to know stuff, especially to talk on here, right? I have no problem if people don't know things. That doesn't mean anything to me. So it's actually one of my rules that it's okay for you to not know shit, but it also means that I don't know everything either. So if I don't know something, then you have to tell me, right, or teach me or whatever. Um,
Mhm.
so the there so this is probably making the a conversation too complicated, but there's technically a difference between actual probabilistic information, what we might call stochastic information, and quantum uncertainty, which is technically the square root of that. And in other words, the probabilities, quote unquote, in quantum mechanics are actually represented with complex numbers. And you might think, oh, well, those are like, they sound the same, right? Because they're both talking about probabilities. Well, sort of not. We're calling them probabilities because that's how we think of the world, right? We think of it in terms of
Mm.
uncertainty. Those are technically different mathematically. And actually, when we axiomatize the systems, like if I axiomatize a stochastic system that uses probabilities and measure theory, it comes out identical to classical information. So it turns out that probabilistic information and classical information are actually identical, that you don't actually get any better chips if you have probabilistic calculations rather than classical calculations. They're identical to each other. But quantum information with complex variables, that's strictly different. You get more calculatability out of it than you would with just general probabilities. But anyway, I'm deferring the conversation because I'm trying to say there's a difference between probabilities and superposition, which is technically true, but in reality, everyone just talks about it as probabilities because what other word are we going to use?
That's really, I know, I appreciate the tangent too. That's like really a wonderful insight. I never had it explained to me like that, but yeah, that is really cool.
Yeah,
Thank
yeah,
you.
yeah. Of course, yeah.
Yeah, I will say you stream really late at night, and I gotta get my ass to bed because I got school in the morning. So, but I really appreciate the conversation, and it was nice meeting you.
Yeah, thank you, thank you. Feel free to come anytime. Yep.
Great, and thanks for the clarification, Bob.
Yeah.
Bye bye.
Let's see. We think of probabilities as a function from x to 1, 0, where x is our sample space, and this subset of the real line. Yes, there's a couple more properties, such as the integral of f over x has to add to 1, right? So it's not just that all the values are between 0 and 1, but they all have to add up to 1. Right. Let's see. 4, 5 people. Oh, I have a bunch of questions on here. Second hardest thing you've ever had a lecture? Well, surely there's a subject. Yeah. I don't know. What would be a subject that I had trouble talking about before? I've had tricky. Yeah, stuff outside of my field is hard. When I gotta explain, like, how some chip works or something, that's always hard. But too many, I mean, most of the time people are asking you to give a lecture on what you're an expert in. So, like, you rarely have an opportunity to do a talk on something you're just not familiar with. Okay, so now I want to choose something you can do outside of math. Okay, can you give a topic and you try? It will be math related. You choose something you can do outside of math. Stuff I do outside of math, I play Go. I do origami. I can do origami. I don't know. I want you to explain to me why, if the world had a 1v1, it would only take 55 matches to win. because 2 to the 55 is an incredibly large number. It's probably less than 55. 55 is way too big, right? It's got to be smaller, right? I don't know. Okay. Let's see. Bohemian mechanics only works if you know the exact position before observation. It's circular, still not deterministic. I gotcha. Really understand how many things. Local variables. Okay. All right. I think I got to end stream a little early tonight, but I appreciate everyone coming. Unless there's any last minute questions or anything, I think I'm going to go. Oh, we have someone new join the Discord. Hey. Well, what are your thoughts on that pastor who criticized Newton's calculus? Someone criticized Newton's calculus? As in what? George Berkeley? I don't know. George Berkeley. Newton calculus hater. In 1734, Irish philosopher George Berkeley. Oh, I guess I should switch to browser. Sorry, hang on. Browser. Oh, I gotta turn it on. George Berkeley. These are the results. George Berkeley in 1734. Irish philosopher George Berkeley published The Analyst, a fierce critique of Isaac Newton's calculus fluxions. He argued that the foundational logic of calculus was full of errors and contradictions, famously calling infinitesimals the ghosts of departed quantities. Oh man, this is what it sounds like when you're in a big discussion with another math person. You're like, no, your infinitesimals are ghosts of departed quantities, you moron. What's wrong with you? No one's going to listen to your lectures, idiot. I don't know. Sounds like my kind of guy. I mean, religious hypocrisy. Scientists mock Christians unlogical. Newton assumed that changing quantities were sometimes zero and sometimes right answer. Okay, I don't know what the AI is trying to tell me. All right. Let's see. You can't prepare or measure the actual hidden position more precisely than this allows, so from your epistemic standpoint, outcome remains probabilistic. True, yeah. You can't prepare or measure, yes, that's fine. If you're talking about the standpoint of observer comes, yes, okay, correct. Okay, guys, I'm going to go to bed. Thank you all for listening and watching. I'll be on again tomorrow. I'm going to do Ask Me Anything tomorrow. Of course, tonight was Ask Me Anything too. No one seems to want to debate these days. Maybe I'll just be an Ask Me Anything guy, and we'll be all math all the time. That's fine. But yeah, I probably need to make my way into like the debate spheres or whatnot on some other night. Maybe I'll do that on Monday or something. Okay, well, good night all. Have a good night. Thank you. Just disconnect quietly. Okay. So that leaves everyone in there? No. Oops. Oh. Oh, I gotta kill it for everyone. End stage. Okay, there we go. We had some props. Your stream says debate night, and what does that mean? Sub to a fellow atheist. Yes, thank you. I'll get you some props up then. Yes, thank you. Thank you. What's up? Yes, thank you. Let me give you a. Can I do a heart on here? I don't know how to do a heart. Can I do that? No. Okay. There. Okay. And then okay, so then I gotta end the stream. Okay,